Day only, and well, some persons also watching online. So let's enjoy again the show today, and thank you, Manuel, once again for. Where's Manuel, by the way? Is he in the room somewhere? I can't see him. He's traveling around here, running around here. But nevertheless, so thanks to the local organizers. Hello, Juan. Good morning. So local organizers for a lovely program for yesterday with the site visit and everything, and of course. The wonderful joint dinner we had. I enjoyed a lot and hope you all who could enjoy. And welcome now to follow then the second and final day of this final conference, ForestValue Final Conference. And today we have then 4 more interesting sessions to listen. So it will be an interesting day again and a lot of input and thoughts for the future, definitely. And then today we will finish with a session called Past, Present and Future, and this session is including then a speech from my dear friend Andreas, and then a very interesting panel discussion we can expect then with our 6 distinguished experts joining the panel. So that will be an interesting closing for today. So hope you can stay for that one as well. And then for practical arrangements, so if there is anyone leaving right after the conference to the airport, so you might want to sign up at the registration desk. So if you need a taxi or something, so we can then collect a groups of people together. So you don't need to then take individual taxis there. So too many. So I guess this is all from my side for today. So let's enjoy it again and welcome everyone. And Karina, my dear colleague from Germany, will take it over from now, and she will moderate the day for today. Thanks, Karina. Good morning.
Hello, everyone. Good morning. I'm happy to see you all again. I'm Karina from the Agency for Renewable. Sorry. Okay. Good morning. Buenos dias. I'm very happy to be here. And I'm Karina from Agency for Renewable Resources in Germany, and I was involved in the call office for both of these calls, and it's been a long process, and I'm very happy to now see the results and plans of the second call. And yeah, so much work, but now we see what we all have accomplished, and it's very nice to see you. Okay. We will start with a session on building with wood from different perspectives. Our first speaker is Carmen Santos from Karlsruhe Institute of Technology in Germany. Carmen, good morning. We will have questions and answers right after the presentation.
So welcome everybody. We start with the first engineering project. So I'm very proud to be the first one. My name is Carmen. I work in Germany at the Karlsruhe Institute of Technology. And the first project is called Hardwood Joint, Innovative Joints and Hardwoods. Who are we? We are 10 project partners where 4 were from research. You see Lermap, that was from France here. Then TU Graz from Austria. KIT from Germany, and the Linnaeus University from Sweden. We also had 6 project partners from industry. What was the project about? Well, to use more hardwoods, to bring more hardwood species into the building sector. Why did we want to do so? There are many reasons, I think. I'm an engineer. Let's look at an engineering reason. Hardwoods usually have a higher density, and that means they have a higher strength in comparison. This doesn't work very well. I do it like this. A higher strength than softwoods. You see the difference here, just schematically drawn. If you want to build with hardwoods, you need building materials. They already exist made of hardwoods. They are inserted in the building market. Here are some examples. But if you want to build, you also need to join your constructions, of course. So a column with a beam, for instance, you here with the red circle. And that was what the project was about, the joining in using hardwood species. What's the challenge here? The challenge is very simple. You have a rather high capacity of the structural members, and the joint capacity usually trails behind. So what we wanted to do is just close this gap a little more. That's in summary the scope of the project. How did we want to do so? Well, we wanted to understand, complete, optimize, and implement. Where for building industry, of course, the implementation, that's the crucial part, because that's what's providing industry with so-called design models so that an engineer can calculate a structure when he wants to build. How do we get to design models? So you have, that's very common in our field, you have a mixture of experimental and numerical work. You do some experiments, you develop, for instance, finite element models, you do parametric studies, you complement everything with statistical analysis, and at the end, equations come out on values with which engineers can calculate. I won't show you this because it's equations and values, so we will focus on the first three, because that's exactly what helps closing this gap. If you understand all load transfer mechanisms in a joint, you can account for them all, bring your capacity up. If you complete, you fill knowledge gaps. That helps, of course. And the final obvious thing is to optimize the joints, so find methods to increase stiffness and capacity of a joint. Let's start with the understanding. Most of you, I think, I don't know if they know, so you have, this for instance is a joint. So you have two timber members, a central steel plate, you connect it with a dowel that goes through, you start pulling, so the load is acting perpendicular to the axis of the dowel, and this is called a joint with a laterally loaded fastener. You do tests, so you start pulling, you open specimens, and then you see how the inside looks like, how it fails, and then you can derive a design model. Here you know that you need to account for this fastener deformation and for the crushing of the timber underneath the wood. You can use different fasteners, so we looked into screws, staples, nails, the ones you've seen with the smooth surface, that's a dowel. I focus in the following on the screws. And here you see the same of the softwoods, because the engineers among you, they will recognize this deformed figure. It looks just like in a softwood joint. So is it, that's a first question, is it similar softwood joint behavior to hardwood joint behavior? So what we did is so-called multi-stage tests to look a little bit closer into this. So imagine you start pulling here on the steel plate, so you measure your load on the vertical axis, you measure the displacement between the steel plate and the timber member, you get a curve. And what we did now is stopping deformations at certain deformation stages. So we deformed up to 5 millimeters, we opened up to 10, 25, and up to failure. Let's look into open joints. Start with a softwood joint. And, well, engineers among you will say, oh, yeah, that's what we know. Of course it is. The surprising thing here is that even at 10 millimeters joint displacement, you see hardly any deformations in the screws. And this, although what we call that we are already deep in a nonlinear range, so you have permanent deformations. That's also, we learned something about softwood joints in the project hardwood joint. That was nice. If we now compare this to a hardwood joint, you can see that let's say, the screw has a little bit deforms differently. You see the bending radii are smaller. You can see it here. So it looks a little bit different, but in general, in quality, it looks the same. What does this tell us? It tells us if we have derived the proper values, we can use the existing design models. But in hardwood joints, we have to account for things we didn't know before. Here you see, it's very hard to see. Here you can see that the screw failed. Yeah, so this is something we need to extend our design models to account for these things as well. So to conclude the first part, just yes, we can use existing design models to calculate hardwood joints with laterally loaded fasteners, but you need to have a little bit more. So you need to account for these fastener failures, and you have very specific execution rules. What's about the completion? So we have spoken about these joints with laterally loaded fasteners here. What about if you insert screws here, parallel to the grain in the piece of timber, and then you start pulling in the screw axis? That's a joint with actually loaded fasteners. And here we also had a rather extensive experimental campaign. So we inserted screws here at alpha 90 degrees. So the fiber direction is this direction. You insert the screws perpendicular to the grain. So it's a joint at 90 degrees. You see that there are many screws. That's also crucial. So a joint with one screw doesn't exist in practice. You also have groups always. So you need to look into so-called group effects. We did tests also at 45 degrees, and this is where the largest knowledge gap was, where we had to complete our information if you insert screws parallel to the grain. Here you see in parentheses this little word short-term, and that's why we had to complement the tests with long-term tests. In particular, for this joint configuration, you want your building to stand for 50 years, but the capacity of short-term tests, you assemble test specimen, you test, and that's the value, is different from when you assemble a test, you load it, and you just let it hanging for quite some time here. So these are, the short-term tests are finished, the modeling is finished, the long-term tests are partly still ongoing, and what can result out of these? This is, for instance, an example for an execution rule. So you need now how far away the screw must be from the edge of the timber. You know how deep the thread should be embedded in the timber to bring the load deeply inside the timber. And you know, for instance, in hardwood joints that you need to pre-drill. That's an example for these execution rules you need. Yes, so now there are design rules available for joints with actually loaded screws. And also here, some certain execution rules need to be respected. The optimization. We've spoken about these lateral joints with laterally loaded fasteners, with actually loaded fasteners. How can we optimize? I think I've shown it in every presentation, the cheese grater. You know, if you grate your cheese, you always make sure that there is cheese between the cheese grater and your hands, because there is a little bit of a resistance. So that's where this idea comes from. You see here, 1, 2, 3 timber members. You see screws that hold the joint together, and you see that this interface here is rough. So here's some examples. So this is not too difficult with CNC machinery of timber producers. They can create these rough surfaces. Then you assemble such a joint, you load it, and now we look at the results. Again, now you know what this is, a load displacement curve. First, we look in a joint without any grooves. You see it is increasing, and then it deforms and deforms and deforms. The capacity would be like 50 kilonewton. You do the same test with the grooves, and you see there is quite a difference. So you get a much stiffer behavior. That's this linear part in the beginning. Nearly 200 kilonewton of capacity in this test result. The joint starts to fail, so you get the shearing here of the grooves. But because there are the screws, the capacity falls back to the capacity of a joint with the 4 screws. So it helps avoiding catastrophic failure, of course. So yes, hardwood joints can be optimized in terms of stiffness and capacity. Here we are not yet at the stage where this can directly be implemented, because you need to look into things such as changes of moisture content. You need to account for, of course, because you need to make sure that the grooves are firmly together. So what we can conclude is, yes, that's now already used in the building sector. So we have design models and the values to design for hardwood joints. But also the industry here, our partners, they have learned that hardwood joints are a bit more complex than the softwood joints, that they are more than only their design models. You really need to look into these execution rules. You need to pre-drill. You need to know how to manufacture this. So you need to look at the whole package and not only at equations and values. And I think at the end, what we can provide with the project is a little bit more diversity in terms of timber species in the building sector. It's not only softwood, spruce, and pine and fir, but now also the most common hardwoods in Europe. And I think that's a nice outcome. Concerning scientific cooperation, I just attached myself to all the comments yesterday. It was just great. Here's some photos of all of us who contributed in the project. And then reflecting on yesterday about the unexpected barriers, I would have a remark. Of course, our unexpected barrier, that was COVID. We didn't have any regulation issues. But another issue for us is to know which species we can expect in the building market like in 20 years. So from forestry, we need to know which species are worth of looking into, because this is still, I think there is still also a communication gap, because that's something we don't really know. Yeah, this was now oak, beech, and birch, but are there others which are interesting? Where do you go to? Anyway, that was it. Thank you for your attention, and if you have any questions.
Thank you, Carmen. I think, at least from German perspective, we are planting so many more oaks and beeches, much more than in the past, softwoods, so that's very important. Do you have questions? Feel free. Nothing. Okay. Oh, there's one question from
Thank you.
Katja. No.
Carmen, thank you. This was very clear presentation. Very good. Thank you. For us.
Because you're not an engineer and you understand that.
Yes, even for us that are not engineers, we could understand. I was wondering if that was the joints. Are they the most expensive part? Not the most expensive, but relatively. What is the barrier to go to the market? We know that wooden buildings are very expensive, but the joints, what do they bring here? Are they an important factor, or is it just technically how feasible it is or not?
There are many aspects as an answer. So in hardwoods in particular, for instance, now in softwood structures, if you look at large portal frame structures, they use huge glulam members, for instance. And they have standard detailing, and this is what the companies are used to. With the hardwoods with a higher strength, but the issue is your stiffness, your modulus of elasticity isn't increasing as much. So you need to look into other solutions, which would be like truss structures. You would save on material. You have slender structures, but then you need a lot of joints. And I think the knowledge is here, but that you need to manufacture them. And the companies just, they need to start doing this. And I think many already do, because in Germany there are quite some hardwood structures now, all in Central Europe. Most of them are beech laminated veneer lumber. So the knowledge is there. And it's still a bit specialized, but it's infiltrating the market, I think. Yeah.
Thank you.
Any other questions? No more questions. Okay. Thank you very much, Carmen Santos. Our next presentation is called Fire and Wood, and I welcome Tian Lee from RISE Fire Research in Norway. Welcome.
Okay, thank you very much for the chair. And my name is Tian Lee from RISE Fire Research in Norway. And I'm glad to standing here to introduce our project, Fire and Wood, which stands for Improved Fire Design of Engineered Wood System. So here are our partners from 5 different countries. So it's quite well mix of universities, a research institute, and also very involved industry partners. And this project founded the first ForestValue call, started 2019, and will end very, very soon. So I think quite a lot of you have been to this building. So you know now wood has been used for quite a lot for constructions. And here only listed some of the benefits using wood as a building material, but also there's increasing trend now to build taller, larger building using primarily timber constructions. So this, of course, brings some new challenges. One of them is, as you may know, wood is a combustible material. So with extensive use of such material in buildings, there's new challenges, new risks related to fire which need to be addressed. That's the reason we have this Firewood project. Here just a figure I think showed a few times before. I won't go into detail, but one thing I want to mention is very thank you for the previous presentation about the engineering approach. So here is very similar, and because we have this knowledge gap, we have done extensive experiments of testings to understand the phenomena, to gather the data. That's why we have this particular work package 3 in the project. All the partners are involved, and we have done a lot of different sides of testing, different skills. It's over, we had rough calculation just at a coffee break. It's like over 2,000 or well over 2,000 experiments has been done in this project, from the small scale non-fire tests to the large scale kind of demonstration tests, because we want to not only understand the proposed models, also to verify and validate our design models in large scale and compartment scale tests. So we were asked by ForestValue to show, okay, what is now the research step you have in a project. So as mentioned before, we found this, this knowledge gap in fire safe use of engineered wood system, particularly these structure joints. As shown below, there are the structure joints and particularly adhesive used in this, with the behavior of that under elevated temperature and the fire load. So here are the things we found. There are design models, but very rarely mentioned the performance at elevated temperatures. If there were some models, but this is very on the conservative side, because it's not backed up with detailed data and theory. And also now for using such things, it's usually often it needs to require very extensive large-scale component tests, which are super expensive. So for the adhesive manufacturers, it's very big cost to prevent such system to be used in the reality, because it's very expensive to test, to demonstrate it's fire safe. And of course, as I said, people know wood can burn. And there's, in general, kind of society perspective, it's like rather pessimistic about, okay, how about you have this combustible material in your home, especially for large buildings, how we should address this. So we have the approach is basically through the extensive testing, we understand the phenomena, we propose those design models, we propose those classification method, and also, very importantly, we have this part, dissemination, communication part. We would like to change acceptance of the public and also give the input to the regulatory bodies so they can implement our result. And later, it's easier for the manufacturers, for the builders to use such systems. Again, this is an example here is how we end up develop this design model, for example, for one of the joints, glue-in rods. So here we have the kind of a story how we end up with design models we propose. But then, again, testing is very essential here. So, for example, in this particular task, there are 4 testing series has been done at different scales, starting from the simple one without fire, small scale, and gradually understand the phenomenon, and adding on parameters we are not know, and continue to gather information and then validate it. In addition, we have numerical simulation. Is also a very powerful tool used in the project. For example, you can imagine one of the most important parameters we want to know is the temperature of the bond line, which is usually inside the specimen. It's very difficult to measure directly, especially to get temperature distribution. So that's why we also use finite element simulation to look at the temperature distribution inside the specimen. And in addition, we compare this simulation shown in the left-hand side and then compared it with experiment data to gain competence of the model, of the testing results. After all those complicated tests and very detailed simulation, what we want to end up with is actually simple engineering model. Well, its equation here is still long, but it's actually relatively easy to use for the engineers. So that's what we want to achieve, and has been developed several of these type of models for even for eye joints, and also simple, cheaper, economically classification method. So also we are asked about the impacts. So we have those design models, we have those classification method. So what we want to do, and we have done, is to try our best to communicate it with different groups. And we believe by having those design models, it's now the lower threshold for the structural engineers or fire safety engineers to design the timber building using those design models. And very importantly, for the adhesive manufacturers, they have now a very simple and economic way to testing their adhesive to fast track their development. And also for the builder, they know, oh, this adhesive belongs to this class, and then what type of, for example, behavior it will be under certain fire load is very clear. So it's easier also for the builder, designer to choose the right adhesive. And it's pretty special. In our project, we have partners sitting in those standardization group, those two certain group. So already we have a lot of inputs already implemented in the draft of the new Eurocode 5. And there will be also hopefully next revision in the TC 193 for the adhesive, where our result also will be used to design those new regulations. So also for the value of scientific cooperation, we are a project group with different background, but all mainly in the fire safety and engineering wood systems. So we share knowledge, and also it's important we also not only share knowledge, competence, but also we utilize the testing capacities, because it's a very testing-oriented project, in different groups. So you can see this very complicated matrix, because we have the partner like Muhoven Speedcon, who produce the timber, and additionally we have external support from Stora Enso, for example, provide timbers. We have very engaged adhesive manufacturers, which are not in the partnership of the firewood, but they are very interested into our results and the project. So they provide additional support to us to expand actually our testing metrics from 2 different adhesive to eventually 11 or 13 adhesive tested. So it's much more knowledge we gained from the firewood. And also we have make the test specimen in for example, the Mason Beam, which is a partner. They shut down their production line just for us to make those specimens. So it's very impressive, and we are very acknowledged for that. And also doing tests in different labs, utilizing their capacities. So lastly, well, those barriers. So it's been talked quite a lot. It's COVID. It's hit us particularly bad because we need to do the test. And unfortunately, due to the COVID, the lab was shut down, factory was shut down, and the border was shut down. So we have to find some innovative ways to do the test. You have hybrid meetings, we have hybrid experiment. So we just try to see, which labs are open under this period. We send samples there. We do the test. Here examples. We have our lab open in Norway, but then we have Dr. Macklina from Sweden and Professor Alar in Estonia online, and try to go through the whole process of experiment. It was some experience. And also we have a lot of online meetings here showing all the minutes of meeting, our repositories. We have a lot of discussions. And also in order to fast track our project after COVID, and we have this additional contribution from external partners. We are very happy to have them. So at the end, thank you very much for the ForestValue for supporting the project. And thank you for all the partners' contribution. I think quite a lot of them are here. please raise your hand from firewood. It's Ruben and Alar. And we have actually an adhesive manufacturer there, which not partner, but contribute a lot. Thank you all. And yes, applause to them also.
Thank you very much, Tian Li. I'm impressed how much industrial support there is. And does it still continue?
Yes. As I said, because of the COVID, it's quite late. But now we have done all the tests. Now it's a very intensive period of time to try to gather the data and because our goal is still to, as much as we can, to publish all the results. Because I think this is the way we will make impact. Yeah. Thank you.
Thank you. Are there questions? Yes, one question there.
Thank you very much for an interesting presentation. I'm Erik Svan, I'm from Lund University in Sweden. You mentioned some of the driving forces behind the project, closing knowledge gaps, and also in some sense I think you said something about improving design approaches because they're in many cases on the very conservative side today.
Either conservative or not existed.
Or non-existent. Yeah. But the question is, what have you found so far to not be on the conservative side of the approaches we're using and have been using for some of the iconic buildings you've shown in your presentation? And if so, what would the consequences for these structures be? Thank you.
Thank you very much for the question. As far as I know, I don't think there are such thing we have found. Alar, correct me if I'm wrong. I don't think we have found that. But of course, timber itself, it's combustible materials. So the design of the joints is one element. So if you're looking at the whole kind of fire safety design, it's not only how you design the joints, and it's also about how you design other things, like sprinkler and early detection. So all the things combined together make the fire safe kind of concept. So I think what we are trying to do here is only one element of that. So in order to design a really fire safe building, it's actually quite a lot of elements. As far as I know, again, back to your question, I don't think there are anything we found now because they are on the conservative side. So yeah, maybe there's something, but again, as I said, if we found something, we will try our best to disseminate the result. If there we found something, maybe it's not on the conservative side, by other means, for example, adding those early detection sprinklers, we can still make it is safe to use.
Other questions? I was wondering, were you using, was it softwood or hardwood?
This is Norwegian spruce.
Oh, Norwegian
spruce.
Spruce.
Because we try to actually, in order to assess adhesive, not wood, we try to use the same batch of wood, same material as much as we can. Yeah.
Thank you. Okay, thank you very much, Tian Li. Now we are going over to a little bit away from the building sector to resource-efficient and data-driven integrated log and board strength grading to the sawmills. I welcome Andreas Weidenhiller from Holzforschung Austria. Das nicht?
That's not me.
Okay.
But you can, it's ready strength, just at the bottom.
Oh, yes, okay. What's this? Okay, thank you.
Okay. Thank you. Good morning also from my side. Nice to be here and to be able to present our results in this way. So my name is Andreas Weidenhiller from Holzforschung Austria. You also see my partners down here, but I am coming to that in the next slides. So yeah, just some basic data to our project. It ended already in March, so we were not hampered so much by the pandemic as the previous speaker indicated. We had a bit more luck in our design here. Yeah, we were partners from 3 countries, Sweden, Austria, and Germany. Our project leader is Olaf Broman, who can't be here today, but yeah, send you his greetings, of course. Yeah, so here again, our partners. We were 4 scientific partners, and Nora Timber is a sawmilling and forestry organization where we did partly our tests. So what is our project about? You already mentioned where we are located, so not in the construction, but in a stage that is essential to it, preparing. We are at the sawmill. And to explain what our project is about, I just quickly go through the simplified sawmill process, which starts, of course, with delivering the logs to the sawmill. Then the logs are split in some way based on visual assessment and, yeah, mostly on diameter and length. Diameter, of course, to select afterwards certain cutting patterns. And so if you want to saw a certain material, you usually pick material with a certain quality, but the restriction is not so much. The restriction is, okay, I select a cutting pattern and therefore the diameter. So I saw the material, I do all kinds of processing, planing, drying, which is, of course, can be very energy intensive. For construction, we have usually moisture contents of 12%, so that's, yeah, quite a cost factor and energy factor. And only at the end, we actually find out if the material is suitable for construction, if it has the strength that we want, which is often done using machine strength grading, some kind of non-destructive testing methods. And so what is it that we want to do or wanted to do in our project? As explained very simply, we want to do the assessment much earlier. So we want to use non-destructive testing already at the log level so that we can predict already at the log level what are the strengths that we can get from this material, and so that we can use the material in a more better and adapted way as it is according to the material properties that we can determine at this stage. As we recognize that we have different types of sawmills, we looked at different, we called it scenarios, so how may different sawmills use these log assessment techniques to optimize their production process. Of course, we looked at different log scanning technologies. I'll talk about that more in the next slide. And we used these technologies, of course, to gather a lot of data. We scanned about more than 400 logs of 4 different species. Then we produced sawn timber from that, more than 1,500 boards. And used the data that we collected in that way to do board strength prediction, where we used 2 different methodologies. One is a classical one using statistical models, but we also used finite element models, as this figure here indicates. And all these data then can be used to optimize pre-sorting, as I mentioned, already at the log stage, so that we can use the best material for the product that we want to produce. So some more about the log scanning technologies. Basically, our models are based on 3 different technologies. One is just 3D log scanning using laser trigonometry, so where we can measure the outer shape of the material, so we get the detailed information of the outer shape, but of course no interior information. Maybe some of the irregularities on the surface are indicators of knots in the inside, but of course this information is rather weak if you want to predict strength. A better approach is X-ray, where we have often, as indicated in this schematic, 2 X-ray sources. So here is the data that we can produce, and you see the brighter, the higher the density, so we can see the difference between hardwood, which is less moisture content, and the sapwood with higher moisture content. And we can see knot walls, which are the bright vertical spots that we can see here. So, and you probably know that knots, they have an influence on the way the fibers go through the board. So these are very relevant to strength, beside the density, which of course we can also measure here. And we can, at times at least, get some indication of how the pith is going. So if there's something dramatic happen to the pith, we also can see it. And the best technology, and from the view of the information you get about the inside of the log, is computed tomography, where we have not only two log X-ray sources. It's just one here, but it's rotating around the log at high speed. So we get a lot of different scanning directions and a lot of information, so that we can actually reconstruct the position and size of each individual knot. Even estimate dead knot border, which is here, the darker part is the dead knot position, and also, of course, density information with a high information and density and a lot of, three-dimensionally. And I'll go through that pretty quickly. So we did, of course, a lot of modeling with different statistical technologies. Here are the four species that we used: silver fir, Douglas fir, Novi spruce, Scots pine. And I just go to the coefficient of determination. 0 means, of course, we can't predict anything. Best value would be 1, which is not here. So strength is difficult to predict. And I just go through one model for each technology and each species. So we see if we just use outer shape, the predictions are pretty weak. But we get much better if we use X-ray to predict. And with computed tomography, we get the best results. So that's the ranges that we are in here. Some perhaps additional information to that. So we have our three countries where the 4 species come from. And the material from Germany and Austria was treated together. So we had the testing and scanning in Germany, the testing in Austria, and the Swedish material was tested and scanned in Sweden. In Central Europe, we were focusing on glulam, so we used tension tests for the final testing, destructive testing. In Sweden, it was bending tests. And also, because maybe I just click on here, we had different dimensions. If you look at the Swedish material, that's spruce and pine, this was very small diameters and only cut 2 main boards from each log. So they used for modeling the average strength per log, and that's one of the reasons that the values here for Novi spruce and Scots pines coefficients of determination are slightly higher. So don't compare too much between the different species. In Central Europe, we have larger diameters and many more boards sawn from the same logs, but therefore we used fewer logs. So in Sweden, we had more than 150 logs for each species. In Central Europe, we had 50 logs from, a bit more than 50 logs from Douglas fir, a bit more than 50 logs from silver fir, but still a lot of boards to cut from that. And so, therefore, it was essential for us to use the correlation between strength predictions for the individual boards. So that's some differences. But the main message is just, of course, the more information we get, the better the prediction we can achieve. And this here is just showing predictions using the statistical models that I indicated. We also used a second approach in the project, mainly done by our project partner LTU, where they used finite element modeling. Again, they started with computed tomography scanning data and reconstructed the knots inside each log or board. And then, as I already mentioned, the problem with knots is mainly that they change the direction of the fiber. And we can't measure the fiber, we don't have that type of resolution, but we can estimate with kinds of simulation how the fiber flows around the knots. And we can use this fiber direction information, the simulated fiber directions, to create finite element models and then do finite element simulations of bending tests or also, of course, of destructive tension tests. And then we can use these to calculate, for example, strength values. In the project itself, it was only done on a very limited sample, so only 10 spruce logs and 10 pine logs from the Swedish data as a very early study. We had 2 different models, so the blue squares are just using this fiber direction information that can also be extracted at the log stage already. And so we have some good correlation with the strength. If we add information of the frequency that you can get when you measure the different boards, you can get an even better correlation. But of course, this means that we have a hybrid approach then, where you use both data from the round timber scanning and from the sawn timber scanning. That's one of the scenarios that can be used. Yeah, so we did a lot in this project to improve strength grading already at the log level. This means that we can better allocate the logs to the different target products and improve raw material efficiency by that. We looked at different ways how sawmills can use that. And of course, we did quite a number of publications in different ways. Yeah, our project did a valuable contribution to log strength grading. It's still not finished. We can continue, especially with finite elements. We had a high added value, definitely, as all the other projects also mentioned already, through the international scientific cooperation, through this ForestValue funding. We used more different wood species. We could use more different scanning technologies. Yeah, we had the exchange, okay, how are things done in Sweden? How are they done in Central Europe? And we found some differences. Everyone learned a lot. And yeah, especially the finite element models, that's something that we, at least as Holzforschung Austria, couldn't have learned without our partners in Sweden. And so we're very grateful for the way that could be done. Yeah, it was a challenge to combine the data from different organizations. It's always a bit different the way people treat the data, store the data, the way the variables are organized. Of course, the pandemic was a bit of a challenge, but as others already mentioned, yeah, the online meetings worked very well, so that was quite okay. And yeah, definitely we want to continue the research, so we are not done there. I think there's more potential, especially in finite element analysis. And yeah, we are very grateful for the connections that were established during that project, and we want to maintain them to continue knowledge exchange between the institutes. And yeah, that's the end of my presentation. I thank you, and yeah, I'm open for my questions.
Thank you very much, Andreas. Are there questions? Yes?
Johan Fransson here from Linnaeus University. Thank you very much for a nice presentation. I was thinking about you focus on the strength. Could you extend this a little bit also to estimate the quality of the wood and use the same data that you collect for this project also into the quality predictions of the wood, or I mean, yeah, or is it going hand in hand?
There are, of course, I think many different definitions of quality. You mean appearance in this way, so maybe not structure or things like that? And things like that, yeah. Yeah. Well, especially when I focus again on computed tomography, which was our main issue here, or main basis here. There has already been some research done on outer quality assessment, visual quality stuff. So that has been done in other projects, but we found that the knowledge of strength prediction in particular has been lacking, and that's where we stepped in and added our information. Maybe I could add, as you already mentioned, okay, strength. There are, if you look at the way that strength grading is done in Europe, we have 3 grade determining properties, sorry, not only strength, but also the density and the stiffness. We also looked at them too, but we had to focus, of course, the presentation here.
Thank you.
Are there more questions? Yes, one here.
Good morning, Robert Master from the European Forest Institute. For someone who is not really expert on this, but it's quite interesting. So how close is all these scanning technologies already for actual production? I mean, you had there also an industrial partner. I understand that there are still things to be learned and the correlation was getting better, but so how far away is this from being actually used, these CTs or X-rays in actual sawmills?
Yeah, it depends a bit. For example, that's also something that we learned in the project in Sweden. X-ray scanning has been established for, I don't know, 15, 20 years or something. So that's something that is being used there. And so these models can be implemented rather quickly. CT scanning is just beginning, in my impression, so that it's pretty new. And for example, in Austria, as far as I know, there is yet no CT scanner in operation in a sawmill, although we are quite a large producer of sawn timber and sawn timber products. So it also depends a bit on how the technology is advancing. Also, we have some issues where it's about traceability. So because the usual way is we do some log scanning, then put all the logs on a stack, and the information for the individual log gets lost. But also there, companies are doing a lot to close this gap so that the logs can be recognized immediately before sawing, for example, and also to track the information throughout the sawmill. And there's one further thing, because the way we do strength grading is always we have some representative sample, and we determine thresholds and limit values for that. And if the quality of the material that's actually graded differs widely from that, then these thresholds are no longer accurate. This is not a problem if you just remove the less strong material, but if you want to use both quantities, the high strength material and also the low strength material, we need to adjust the strength grading to the low strength material. This is possible in the current standardization framework. You can do it. Just need to change your representative sample, but it's more complex and hasn't been done yet. But it's something that, yeah, is, I think, also a challenge in a logistical way in a sawmill. So there's maybe some more things that need to be done, but I think we are not so far away from industrial implementation.
Thank you.
Thank you. Yes, you said there's much more to be researched on this, to be looked in. Yeah, I would be interested in the economic perspective here too, but that's in the future too, I guess.
You mean
how much? What's the advantage if you use this? Like how much more good boards you get out?
I'm very interested in this question too, and yeah, I've been trying to quantify it. Maybe that's just my deficiency, but somehow, I didn't manage to get a good number. So I don't know how to really go about this. I think I'll need to learn more, maybe also about sawmill processes, which can differ widely, and the assumption. Which assumptions are important in this way. So I'm sorry to say I can't give economic value here. Yeah. It's still hopes and things that, okay, everyone wants it. Everyone, that's clear. If you talk to sawmillers, everyone wants to know what's in the log before they saw it. And for some special assortments, already the economic benefit is huge. We learned that also from the sawmill producers. For example, large diameter timber, if you're using a special material and you know that, okay, if you cut it, maybe it's rotten on the inside and you don't know, and then it's low value, or it's good and then it's high value, and if you know where the rot is, you can adjust the sawing. So there are some benefits that are already in operation for special products, but for the mass production, it's I think, a bit more complex, especially because there's not really such a big market for the high-strength timber. It's all of the products we are talking about cross-laminated timber later on. It's usually standard products, standard strength, which most of the timber achieves. So that's not the thing that we really need to be concerned about. So it's difficult to find, okay, how do we approach this? So yeah, there's I don't know, maybe a conceptual challenge in my mind, but I think we'll get there, and yeah, I hope we can continue this research.
Thank you very much. Okay, now we get from timber logs over to composite materials, to be exact, to high-strength cellulose composites. I welcome Ingo Burgert from Zurich in Switzerland. Welches ist das? Dieses hier? Ich sehe das nicht. Oh, yes. Okay.
Thank you very much for the introduction, and also many thanks to the organizers. It's great to meet in person again. I would like to present to you our work on a novel material concept for high-strength cellulose composites. Before I start with the objectives and the concept, I would like to introduce our partners to you. So we had partners from BASF, from Aalto University, Stockholm University, BOKU, IB Steiner, Stora Enso, and Rötlisberger AG. And it was a well-balanced consortium, I would say, because we had 4 partners from academia and 4 partners from industry. So what is the general concept of this, this project? We heard already, although difficult to predict, wood has a very high strength, and it's a very valuable material in terms of using it in applications. But there's, of course, also the possibility to go beyond and to further enhance, particularly mechanical performance. So the basic idea or concept here is that we take the wood and we delignify it. So this is not something new. You know it all from pulp and paper production. But the main difference here is that it is a delignification which is structure retaining. So we keep the excellent hierarchical structure of the wood, so we don't go down to the fiber level. And this means that we can keep the fiber directionality, and with this, a lot of beneficial advantages of the wood structure. What you can then do is that you either use this increased porosity for an additional functionalization, or you have a rather facilitated densification process, because your cell walls, when the lignin is removed, become less rigid in the transverse direction, so you can very easily compress this material. Our objectives in the project were to develop cellulose composites with high strength and high stiffness, exactly by this process, having functionalization for additional properties. What is quite important, I will come back to this on the next slide, is also to design adjustable resin matrices. And of course, since we would also like to see these materials in the future, in practice, working on upscaling to industrial processes for prototype geometries. First, I would like to give you a brief insight of how this structure retaining delignification works, or what are the material properties. So here you see a delignified spruce wood which is still in the wet state, and this is also some interesting feature it comes along with it. So in the wet state, it can be very easily deformed. You can shape it, and you can bend it, curve it, and also, like you can see on the lower image there, if you then dry the material, it becomes hard and stiff, but you can then retain also the deformations you have applied before. One aspect very important related to upscaling possibilities is, of course, to which sizes and geometries of the material you apply your delignification process. And here it certainly does not make sense to try to delignify a beam with a large cross-section, but of course industry processing gives us here also some opportunities. For instance, that you take veneers, which you can rather easily delignify, and then you can assemble them, stack them to various like plywood or LVL analogous structures. So we look into the mechanical performance that can be achieved. You see here, how can I point? Is it possible? Or? Okay, so you see on the left-hand side the advantages that come along with a densification of the material, so you can really reach very high tensile strengths and properties and moduli of elasticity, so in the region beyond 500 megapascal or beyond 60 gigapascal respectively. What is of course important if you then would like to implement such materials, and you have seen on the one hand it's of course very nice if you are able to shape your material in wet state, but for an engineering application this can be of course also quite a problem because you have to protect your material against humidity changes. And here of course infiltration with a resin matrix helps a lot. So we applied here various systems. For instance, in the beginning we used epoxy, but also other cross-linking agents which are known from wood modification. These were mainly to define the right parameters, because in the end, and I will also come back to this, it was also important for us in the project to have a bio-based resin matrix in the end, not to spoil the sustainability aspect of the cellulose scaffold as such. On the lower right, you see plots which show you the potential of the materials we have worked on. In this case, it was a infiltration with epoxy matrix. On the left, you see the tensile modulus. So wood is, as we know, about 10 gigapascal in modulus, and on the x-axis you see the fiber volume content, which can then be increased by different levels of densification. So dV would be then the delignified wood, and the orange dots relate to glass fiber composites that you used for comparison. And the blue ones are the one then with these cellulose scaffolds impregnated with epoxy. And here you see again we can go to up to 60 gigapascal in modulus, and also if you look for strengths, we reach with high fiber volume contents, we reach strength values in tension of about 500 megapascal. So really far beyond what usually wood offers, factors of 6 around. So that of course brings us also in the position to address completely new applications with such a material. I also mentioned already the functionalization aspect. Here we had different projects in one of the work packages. One was about further functionalizing the porous structure. Here you see cellulose fibril-based foams in the wood scaffold, so to use the porosity, for instance, for acoustic damping or also thermal insulation properties. On the lower left, it's an example that you can also more or less work in the other direction to not having very strong materials, but also rather soft ones. You can see here a composite made from cellulose and gelatin. And what is here quite obvious is that you have a high anisotropy of your structure. So this is the bar you see on the top. This is the composite with a fiber direction along this specimen, and the other one, which was very flexible, was perpendicular. And this allows us also, so you see there's a wide range of properties you can address in different combinations of cellulose scaffolds with matrix materials. And here we would like to look further into directions like also biomedical applications, for instance. Then on the right-hand side, you see work in the direction of also working on the increasing the toughness of such composites, in particular if you look into the interfaces between individual veneer layers. And here different modified silk proteins were applied as adhesives for having then much tougher materials related to strain to fracture and the strengths that can be achieved in the end. One important aspect of the project was, of course, the upscaling. So not to stay at the lab scale with small specimens, but really go further. And here you see a pilot which was then installed by Stora Enso, which allows to delignify veneers of a size of 1 square meter to have demonstrators ready. And we were very, very happy after Corona pandemic to be able to also have a stakeholder event it's a EMPA Nest in Dübendorf, where we could show various demonstrators, also the upscaling probability that you can nicely shape these materials. And on the right-hand side, you see also here one example of the infiltration and of the cellulose scaffolds with a bio-based resin matrix, which was provided in the project by BASF. Also some other more larger scale demonstrators from Boku with different delignification and densification approaches. Okay, so the impacts, as I already mentioned, we had work on the implementation towards having stakeholder events. And this event was really nice. We had more than 20 stakeholders and this was also important from very different industries, because we wanted to get also their feedback, how they see potentials to substitute less eco-friendly materials that they are currently using with these materials. And on top of this, there were several bilateral stakeholder meetings, particularly with Stora Enso, BASF, and ETH and Boku. Related to scientific impact, we have already 10 research articles published or accepted in peer-reviewed journals, and there are some more in preparation, which will come most probably next year. And then several presentations to scientific congresses. The value of the scientific cooperation. What I liked a lot about this project was that we could have this well-balanced combination of fundamental and applied research activities. I said already in the beginning, we had these 4 partners from academia and 4 from industry, and it was nice to see that they were all committed in terms of developing these materials and to make a step towards this upscaling. And this was very nice to see. And although, of course, also we were like all other projects were affected by Corona pandemic and related measures, and there were some delays, but I would say in the end this project really helped us to make this upscaling, which would have been not possible if we had not this direct contact with the industry right from the beginning. So the final outcomes of this project I summarize as such, that we have an optimized and scalable process to produce such cellulose composites. We see the potential, and also from the stakeholder feedback, to substitute other materials in various fields of application. There's possibilities to further use this increased porosity from the delignified scaffolds to functionalize them in various directions. And what I also was happy to see towards the end of the project, that we had this extensive stakeholder involvement. This, I'm at the end of the presentation, and many thanks for your attention.
Thank you very much. Are there questions? Yes, Andreas?
Ingo, thank you very much. Very impressive. I had the pleasure also to meet your nest some years ago. What kind of functionalities can you do in addition to what you presented today to have very intelligent materials in future, with very specific applications or in combination with others? Because I think this is just opening up a new field, doesn't it?
Yeah, this is a very good question, and certainly a direction that interests us a lot, to also use this delignification protocols to be able then to make, for instance, smart materials. So, for instance, this delignification, when it's structure retaining, also helps to have an enhancement of the piezoelectric properties of wood. So wood is piezoelectric because of the semi-crystalline cellulose structure, but the deformability is not large enough. But if you delignify, you can very easily reversibly compress it, and then you can use this as a sensor material, for instance. So there are various fields where this structure retaining delignification offers opportunities to go further, in sometimes in quite different directions. So I'm very happy that we have a protocol which we can use now as a fundamental basis to go in various directions.
Any further questions? No? Oh, yes. One.
Thank you very much, Ingo, for a very nice presentation and impressive work. And just out of curiosity, because you didn't mention a possible barrier here with this technology and the companies involved, what about the intellectual property rights and these issues? How open is the field?
Yeah, also a very good question.
Or you're not allowed to say?
No, I'm allowed to say, because we already filed the patent application very early. So I think there is not really an issue about that.
And that's
the delignification and densification protocol. But there are also other ways of doing this, other groups working in similar directions, and I think they also have protected their IP, but I think we are on the safe side here.
Thank you very much, Ingo Bogart.
Yeah. Thank you.
Okay, last presentation for this session before the coffee break is on use and reuse of wood building components and on the innovative design. I'm very much looking forward to this presentation. I welcome Karin Sandberg from Sweden. There you go.
Yes, my name is Carmen Santos, and I work at RISE Wood Technology. And I'm going to present the In Future Wood, or as you can see, innovative design for the future use and reuse of wood building components. Is it possible to use this one? Yeah. As you can see, we have quite many partners in this project. It was 22 partners. So it was 1 research institute and 7 universities and 14 industry partners. And we finished this project the last of February this year. So we have finished it. in this field, we have tried to answer the question, how should we build today to be able to circulate timber tomorrow? And this is a quite new subject. And we can also ask, why should we do this? Why should we reuse wood or recycle timber or wood? There's several reasons. One of this is that we really have to reduce the waste from buildings. But also that we are using too much material today. As you know, everybody knows today that we are using 1.7 Earth every year. So we really have to be careful about the material we have on Earth. So this is a really important, and there's something we really, really have to do. And try to figure out how we should build today to be able to circulate tomorrow. We divided the work into 5 areas here called work packages, but every work package is one research field. So we try to put this question into the whole context. As you could see to the left, you have the inventory, destruction, and quality of recovered wood, and that's work package 4, and work package 5 is properties and grading of recovered wood. So those work packages were working more to this material side, the properties of wood in buildings. And the right side was working more against the the question concerning how to build and the regulations against that part. So then we have the work package 2, design out waste, and work package 3, product design using recovered timber. And work package 6, they worked with this environmental and economic assessment for the design for use. And we have focused on design and reuse and quality. So some of the results. For this inventory, destruction and quality of recovered wood. So first of all, it was a great deal of inventory. So what kind of buildings are there today? How much from the building that are built today can be used in future? But we also, when you have destructed the timber, as you can see here on the photos, we took in and it was measured and also this demolition process you can see on the left. We was visiting demolition process, and there's also a movie in our website you could follow up and see a result from that. And this put some set of criteria for that could be interesting to follow up. And I also have my colleagues from Spain here that was working a lot with this, so all questions later can be to over here. So it was some of the parameters that was investigated from the building site. So the question here to answer was what kind of reclaimed wood that is currently available in buildings, and make models for that. And the results from this testing and grading of recovered wood, and some kind of specification and properties of recovered spruce and oak. And here material was from roof, from a bridge, and from housing. So they was collected, and it was also sorted, and it was also tested non-destructively, and the mechanical testing, and of course models, as everybody else has said, make models and compare them. And also this is a video in our YouTube channel that explaining how it works. So this gives the potential alternative grading of this framework. So then we have the mass timber products from recovered timber. And here the main purpose is to utilize material from the existing buildings into new products. And here we show the CLT panels, but also GLT was produced and tested. So always here is also the parameters they've been testing and making models. And this will give the potential use of recovered timber from demolition into manufacture of mass timber construction products. And then we have work package 2, designing out waste. And in this work package 2, the main goal was first to design buildings, especially to facilitate disassembly rather than demolition, and also increase the efficiency of material use by optimizing the primary design. And to do so, we invented 3 methods, as you can see here. And the first one, to the left, is the method to adapt existing design. And this method was mostly for the researcher. And then we have this indicator system, like a rebuilding index. And it was more for the industry, so they can compare themselves to others, see if they improve or not. And the one to the right is the decision matrix. And this is for architects that when they are planning the structure. So we have these 3 methods, and then we have 5 case studies. You can see the 5 houses, and it was 2 from Sweden, 1 from Scotland, 1 from Ireland, and 1 from Spain. And so we tested, and the industry partners were really into this and helped us to think, and we helped them to think. And this gave this new solution that you can see in the bottom, and but also this guidelines for deconstruction and reuse. So we have really tried to work with from reality, see how we could improve the designing out waste. Of course, we have looked to the construction details in this. And then we have the environmental and economic assessment, and they have developed a system boundary, but also how to look into these life cycle scenarios. And they have had special focus on demolition phase in this, demolition phase for timber structures. So the results, as you could see to the left, the normal way of handling timber buildings is to just demolish them. But there are promising results, as you can see to the right. There is one building that was taken down, and it was moved and deconstructed again, and it's from Sweden. And we was following that process in the project also. But we can say that the design for deconstruction and reuse can be implemented with rather small changes in existing technologies. But we also can say that this design for deconstruction and reuse can contribute to the environmental impacts of timber frame constructions for residential buildings. And the products from recovered timber tested structurally show similar properties to Eveclian, I can't say it, new products. And environmental benefits can be achieved from use of recovered solid timber in high quality CLT panels. And recovered spruce and oak show promising results of stiffness and density compared to new timber. And a new framework for strength grading was developed, as you can see down to the right there. You have the schedule for that. And the last, there's a huge amount of existing buildings with potential for reuse in the future. So what's the impact? We have a lot of impacts. Since this was the first project where we really tried to reuse timber buildings and see how to do it, we have done a lot of new work. But we have these 3 methods, but we have also practicing this ISO standard for reuse on these case studies, and it shows to be very difficult. And but as you can see to the right here, we have the industry partners that have been very into these case studies, and they have all of them find things to do in their own production to improve and to make it more circular or reusable. And we also have other things there. We have a stock flow model to predict the volumes of mass timber in the built environment, and also this logical for measuring the quality of reused timber. And this can be used for policymakers, researchers, standardizations, and we have also been involved in this standardization work also in some parts of it. So the value of scientific cooperation, and here I say that's absolutely necessary for a topic including this whole value chain. And we have learned from difference in constructions, methods, supply chains, because in this we have calculated transportation and other things for this LCA and L. And the building regulations, they are different in different countries, and the standards and culture between the countries have been rather big in the way you built the houses. So they are not the same in different in the countries. So we have sharing knowledge. We have written a glossary of terms to understand each other. We have education material. We have study visits, some of them digitally because of the COVID. We have national project that we have showed each other the different national projects ongoing. We have shared reports, and we have also written big pile of reports, about 1,000 pages reports in this project. And to the right you can see the compilation of the reports. The summary report is not so much to read. But we have done a lot of work, and we have also had an international webinar that more than 100 persons visited. And we have also had workshops with our stakeholders. And the stakeholders for this project is mainly municipalities, architects, wood component suppliers, timber house manufacturers, and demolition companies. And here you can see the address to our YouTube channel. There we have about 17 videos explaining what we have done. And here we have two of the industry partners explaining in the seminar their part of the work and how they are going to have used it. So, unexpected things. Well, the only unexpected was COVID, as for everybody else. But the barriers we can talk about a little bit in this point. And what we are doing now is moving away from the current state. And that has many challenges and also obstacles. And that can be an obstacle for this implementation. Since we are dealing with building regulations and standardization. And some of the methods we have worked with, they need to still to be more developed. Because gathering this required data for wood characterization, product certification, development of indicator system, design matrix, and etc. is a very, very large task. And this was a rather small EU project. And the solution is to cooperate and also collect the material for and the knowledge in further project because we can't say we have everything yet. There are many different kind of wood species to investigate and so on. But I will finish here and say that this is Sara Culture House in Skellefteå, and it was planned to start to be built about 15 years ago, and now it's built. 1 year ago it was finished. So it takes time. It takes time to make changes, to collect all the information, to make the change. So it will be possible over time. And here's some of the partners from the project. So it have been very many people involved in this project. And that's all.
Thank you very much, Karin. We have time for one question. Who wants to see this, to ask?
Oh, there's one, two.
This one. Oh, yes, okay.
Thank you very much for the for the presentation. Just one question. You mentioned at the end the product certification. So how this type of reuse wood being certified right now? Is there any regulation on that, or?
What did you say?
The product certification part you mentioned at the end. How right now this type of reused wood being certified?
No, it's not yet.
Not
no.
yet. Okay.
Then it will be up to the manufacturer to do it. So they haven't gone that far yet. It's quite expensive to do it. So.
All right. Thank you.
Thanks, Karen. Ed Suddy from the UK, BRE. I'm wondering around circular economy and deconstructibility, demountability of buildings, and how much of the challenge is a material-related issue, like we're seeing here with wood, or whether it's more about a component issue, like a wall panel or a floor structure that actually might have multiple different materials in it. Do you have any thoughts on that?
Yeah, there are actually different in this circular part where you have the planning stage, you have the building stage, you have the use phase and the second use phase. You have different problems in different parts. So material is one part. But then we have the waste management. That's something that there's no waste management for wood or timber. So there is no affairs making where you can buy and sell, for example, or very small one. There is, but there's not in the big scale. The regulations and the standardization, of course, they are not made for reused material. So that's one part. So there is different things that need to be worked with to fulfill this circularity field for circularity of wood building materials. We are not there yet, but we have started.
Andreas, it's already half past.
Just a comment, quick comment, Karen. Perfect what you said. Probably you heard of the Wood Circus project. We have published the white paper in December last year. This is exactly underlying what you're saying. We need new harmonizations. We have already good performers, but we need to do much more that the circular economy concept will be fully implemented in our sector, but we have the potential.
Can I add to that as well? The Horizon 2020 Circuit project, which is looking at the whole ecosystem around circularity, and one of the study cities, London, actually is piloting timber as their material resource. So exactly that point, Karen, we need to get to the point where people are demanding these materials and they have confidence in reusing them.
Yeah.
Very important.
Yeah, and we have had meeting with a lot of these other projects, ongoing projects meetings, so it's a lot of ongoing things also.
Thank you very much, Karin. Very important work. Okay, let's go for a coffee break and be just back here just before 12.
Siis varmasti tulee olemaan tapaamisia, me kytketään siihen ForestValue kakkosen. Siitä meillä on vielä päätös mitään, mistä mikään
So good morning, everyone. Just a very brief message to let you know about the guided visits at 1:10, right after the two sessions coming now. I think we can manage to arrange two groups of 25 people. So, I mean, maximum 25 people, so I think we can manage. There's also a last visit arranged for 16, but since most of you will be leaving or will have to be leaving, I think it makes sense to gather two groups before the rain that should be starting at 2. So it makes sense to make the tour at 1:10 before lunch, which will be indoors today. And well, the path is already signed, so that's it. Once we finish the session, there will be the two guides in the coffee door. That would be the meeting point. So that's it. Enjoy the session.
Is there someone interested at 4 o'clock to do the botanical garden tour? Okay, so we skip this. So if you want, there's an opportunity later. Okay, welcome back. I hope you're refreshed. There's lots of new, interesting things to get your head into. And we now continue with bark build, a project I was thinking before of, but when there was the talk on fire and wood, they did all this research on adhesives, and I was wondering whether there could be interesting connection between you. So I welcome Mika Sipponen from Stockholm University in Sweden.
Okay, thank you very much for the introduction, and good morning, noon everyone, and it's fantastic to be here and part of this community. So thanks for the organizers also for bringing us together here. So my name is Mika Sipponen, I work at Stockholm University, and I'd like to just give an overview what is our project Bark Build about, and a bit of our ambitions and how we have started. So to start with, first of all, this meeting brings us together for the first time. Many of the partners actually haven't collaborated before, so it's a fantastic opportunity also to meet face-to-face here. We have Stockholm University, myself and my colleagues here, also InnoRenew, Slovenia, Matthew, are you somewhere here? Yes. And then we have Latvian State Institute of Wood Chemistry, Janis there, and then Nibio from Norway, Andreas, and VTT from Finland with Mark and Petri. And then we have one more partner from Warsaw, University of Life Sciences in Poland, and not participating here today in person. Budget is about 1.7 million, and we started officially in March, and since after summer holidays we have had a few months of active project now ongoing. So how we basically came together is we have this joint interest in forest and nature, of course, and we know that forest is a fantastic source of functional materials. And we actually also know that we have lots of forest coverage in Europe, average 43%, up in the north, Finland, Sweden, close to 70–80%. And this is a good source of materials, as we all know. We were specifically interested in the bark as a functional material. We know that it's a protective layer for the trees, and for many other projects, we have learned that actually there's a large supply of bark in Europe, and this bark is already centralized. It's in the wood processing facilities. It's available in large quantities, about 23 million tons. And this makes it a very relevant resource for materials. So our idea is basically to change the current practice where it's combusted for energy and even needs to be landfilled, and instead use it for new materials that can be used back for wood protection and wood building. And if we have here, of course, we have a picture of birch bark, and then we have a composition of softwood bark, not exactly the same, but roughly half of the bark is made of polyphenols, lignin, tannins, then there are extractives, and cellulose and hemicellulose, the polysaccharides, make approximately half. So this is a rich source of materials. So for this project, as I said, we have 6 different countries and partners. Then we have also industry advisory board. It's in the stage of getting formally established, but all the partners of the industry advisory board are also committed, and therefore we have a strong value chain proposal going from industrial residues back to industrial wood treatment and wood building products. And for this we need the bark sourcing, and we have discovered very well with Holmen, for example, and then we have a fractionation technology. So this is, in a way, it's a biorefinery process where we need to unbuild first the bark components to get so-called building blocks that we can use to, with minimal chemical modification, to develop formulations that can be then used for different ways for wood protection. And of course we want to demonstrate the applications and the prototypes from this process. And finally also to assess the scalability and also a bit of the sustainability and the techno-economic feasibility as well. So in this picture I'd just like to give a kind of overview of this fractionation and rebuilding process of the bark. What we can do with these fractions is, for example, with the polyphenols, they can be extracted with alkaline cooking as a soluble extract, and we can, for example, make lignin and polyphenol nanoparticles or colloidal dispersions and to make dispersion coatings. But we can also have this lignin or polyphenol containing cellulose extraction shown on the bottom, this brown fiber fraction, and make, for example, microfibrillated cellulose, and even combine these two to arrive to different products, which could be, well, the focus here is actually that we have indoor and outdoor applications with very different requirements. So for outdoor applications, we are interested in the wood coating, protective coating against weathering, microbial stresses, and also impregnation even for the underwater environments. So pretty broad scope. And then for the indoor applications, we also have an interesting link to the next project that will be presented, since we are also interested in the healthy living environment. So having this composite materials that can also capture some volatile organic carbon emissions. So we have pretty broad scope of ambitions here. And we have a long list of technological and scientific impacts, what I don't want to list here in detail. But if we want to talk about impacts beyond the science and technology, I think personally, as the coordinator here, I see this as an excellent way to bring together different interdisciplinary skills, from engineering to materials chemistry to sustainability assessment and so on, and basically build up new concepts for making this type of value change from industry back to industry. And of course this European network, not only within the project but within this community, is a fantastic opportunity. Likewise, we are very proud that we can train new young early career researchers, PhD students, master students, and hopefully also actively involve them in these meetings. So a bit of the scientific collaboration, cooperation. For us, it's very obvious because we are not just like benefiting from that, but we are dependent on our collaboration in many ways. And I think it's great. Personally, I don't know as much of the, let's say, cellular tissue level of wood, but I think I'm able to learn and already have. So this is very crucial. So now we have, like I said, a few months of active project time. We started all the activities for the most part, and consortium agreement has been signed. This was a good practice also. New recruitment have been in place. We will have a first in-place meeting here tomorrow with like a satellite meeting. We already have one publication which cites the ForestValue project. Of course, hope to get many more. And yeah, website is also launching soon, so please follow up to that. I hope I can promise that within 2 weeks or so we have it up. So to summarize for our project, we see a lot of opportunities for using bark. We have a good commitment from the industry, also good networks to key players there. So we hope that we can use this bark as a kind of natural material for wood protection and wood building, and hopefully build up something which complements also other projects within the program. With this, I'm happy to answer any questions, so thank you very much for your attention.
Thank you, Mika. What questions do we have? Yes, this one.
Thank you, Mika. Ed Suddy from the UK. So the intention is to replace the polymer component in wood coatings with a bark-based polymer structure?
Yeah, that's one of the ambitions, yes.
Okay.
So to arrive at hopefully even biodegradable, at least with a more bio-based formulations.
So that's my area of interest then, is about the stability
of
those systems, photostabilization, lignin being highly photo-unstable.
Yeah, that's we are aware of this, of course, and here that's part of our technical testing, let's say, palette. So it's always a trade-off if you talk about even biodegradability and then the performance, long-term stability. Of course, we need to find a balance here, and this is of course what we want to try to find. So also we have very contrastive requirements for the indoor-outdoor versus the underwater and in the air environment. But it's an excellent reminder of this point.
Hello, Rosario García Gil, SLU, Umio. Yeah, I want to ask about the underutilization of bark nowadays. What is the volume of it? How much is underutilized?
Thank you for the question. I think it's a quite also complex question. It involves how we define underutilization. The energy value of the bark is, of course, important as such. Today, we will see how the reforms of the Renewable Energy Directive and other policies will change. But I think industry is prepared for that. They need to actually start using these type of side streams for actual material development rather than for the energy. So I mentioned this 23 million tons. You can compare that in the scale of plastics, for example. Synthetic plastics is about 380 million tons per year or something, and the synthetic wood protection coatings are in the range of something like millions of tons, maybe up to 5-10 million tons. So I think we are in the good range in that sense. There's good potential. Thank you.
There was one more question.
Tianli RiceFire Research. Just very quick question, because there's still some inorganic part in bark, although quite small, but much more than stem wood. Have you ever considered the use of those inorganic part?
Yeah, that good question. I wouldn't say that is a core component in this project. Somehow I don't think we even want to follow in very much detail how it goes and how it fractionates in this cooking process. But sure, it's of interest, but I think it's not central to this project. Maybe if we talked about like agricultural side stream residues, then it would be a bit more central. Here we kind of left it a bit out of scope. Yeah. Thank you.
Thank you very much, Mika. Now we touch an area we haven't touched so much before. It's wood for health. So health, and I welcome Pekka Kilpeläinen. Hi. From the University of Oulu.
All right, thank you, and hello to everyone. Regarding the many good well-being properties connected to wood, one would expect that wood would be used in hospitals and other healthcare buildings at least equally much than it is used nowadays in schools and kindergarten, but it is not so. And our project aims to study how the use in healthcare buildings could be promoted and increased. So we have 7 partners from 5 different countries. University of Oulu is the lead partner, Professor Vesa Virtanen is the principal investigator, and I'm the project manager of the project. Other partners, there are 4 research organizations and 3 companies as partners. Of companies, 2 are Latvian and German company are working with coatings, paints, and Latvian company also with all other applications for plant oils. In addition, there is White Architecture from Sweden that is successful and large, actually gigantic architect office that uses pretty much wood in its design and has awarded several prizes in wood architecture, and is also at this moment nominated in a short list for World Architecture Forum list. And so we were a little bit unorthodox with the project, and the first partner started already 1st of February, and others have started then later when they have get the decision from the national funding bodies. We thought that it will not harm our research plan, and in that way we will get, for example, plant oil-based products for testing at first, and then others come a little bit later, and they are not there all at the same time to work with. And as you can see, we have been able to meet already face-to-face. The meeting was last week in Göttingen in connection of annual meeting of Northern European Network of Food Science and Food Technology. So if we think at first these things with timber and wood, which has prevented it from being used in hospitals, there are, of course, it's regarded to be prone to contamination, difficult to clean. And then there is not so much instructions and guiding how wood could be used. Anyway, hospital, different spaces, rooms are pretty much under regulation, what the surfaces has to stand and so on. And anyway, then exposed wood or wooden surfaces would have many good properties. Wood is able to buffer indoor air moisture, temperature, that could lead saving of energy. When it comes to heating, it has been calculated that buffering property could save 5% of energy, in cooling even a bit higher amounts. Woody, its color is pleasant, and in several studies it has been shown that short time exposure stay in a room, wooden room, decreases stress, anxiety, heartbeat, hypertension, this kind of things. The last bullet point there, they are objectives of our project. We will develop new coatings that would maintain the buffering capabilities of the wood, but would make wooden surfaces easier to clean and would be antimicrobial, and they have to be also tolerant to those, for example, cleaning procedures which are used in hospitals, disinfectants, maybe also UV sanitation. And we will provide the first extensive guideline for use of wood in healthcare buildings. This slide just shows the structure of the project. There will be 6 work packages, which I now then go a little bit more in details. So, a little bit as a starting point, we use Queen Silvia Children's Hospital in Gothenburg in Sweden. It was designed by white architecture, and there exceptionally lot of wood was used. And we take advantage of that, think and study or utilize experiences obtained from there. And then also think which opportunities there would be to use more exposed wood in hospitals, which knowledge is needed so that wood could be used more in hospital conditions, and also which regulations this food have to, all these new wooden products have to meet so that it could be used in hospitals. This is not based only to Queen Silvia Children's Hospitals, but then in addition we collect good practical practices, experiences in all partner countries that we have started already, and also collect national regulations from partner countries when it comes to hospital building construction. And these are then collected together to a guide we prepare or we write during the project. All right, then this coating development, and it's not really my expertise, I'm just a biochemist, but there will be 3 coating approaches are employed, and they are at different TRR levels. They have, our polymer chemists have designed some, or they have plans to use some innovative synthesis of non-leaching functional groups to the polymers. There will be non-film forming and film forming coating systems, and also natural polymers will be tested. Those have antimicrobial effects. And then, of course, these new compounds will be analyzed, studied, then new coatings, and also coatings on surface for their technical, environmental, and economic performance, also their hygienic properties, mechanical and chemical resistance, photostability, and flammability, and water vapor damp diffusibility will be studied. This later one, water vapor damp diffusibility, is important to check that this indoor air moisture buffering capacity is maintained. Here, partners from Germany and Latvia, 4 partners, they are mainly focused on this coating development. They have polymer chemists and these experts. Then Norwegian partner does mechanical chemical resistance testing, photostability, and flammability, these kind of tests, and our role is then hygiene. How cleanable these things are, how antimicrobial, antiviral they are. And there we start really testing from new synthesized compounds and coatings, and then also test various surfaces in building also how they collect microbes. All right. Okay, and there is then a little bit more about the guide set, or I have mentioned this already. It will be one of the main products of the, or outcomes of the project, but there will be other dissemination activities, of course, also. We have already a web page for the project, And we have LinkedIn account. Those can be found, I hope, using the project name, searching by the project name, and then impacts. All right, as I explained at the beginning, currently wood is not used so much in hospital building, healthcare buildings than one could expect based on its good well-being properties. And it's known that the highest potential in immediate future in wood construction is in public building. So hospitals in public building or healthcare centers, it should be this kind of category where wood construction could increase significantly. But the major impact outcome of the project itself is maybe that we aim to give stakeholders, investors, decision makers, architects, engineers, security, that they acknowledge that they are then able to safely choose wood and wood products for their design and construction work. Value of scientific cooperation. All projects presented here are multidisciplinary, and it is often a really positive thing in international networks. I think here we are maybe even exceptionally wide. We bring together expertise in architecture, wood chemistry technology, polymer chemistry, microbiology, measurement technology, and coating development. Also plant oils could be there mentioned, knowledge of natural compounds and their properties. And then, of course, if we think compiling a guide that should be applicable and could be used in different European countries, it would in practice be impossible without transnational network. Here are contact details for our partners, and thank you. And if you have questions, I try to reply.
Thank you. Okay, room for questions. Was all clear?
Oh, I don't know, or then terribly unclear, but thank you.
What will follow now are 2 projects on cross-laminated timber. Ladies first, Marie Johansson will be our first one. Here you go.
Thanks. And this is not actually just cross-laminated timber. But we go back to the buildings now with this dynamic response of tall timber buildings under service load. So my name is Marie Johansson. I work at RISE in Sweden. And we have almost finished this project up with partners from Sweden, Norway, UK, France, and Slovenia, where we have actually chosen to combine knowledge from timber engineering with knowledge about dynamic systems and what actually happens with dynamic loads coming from other businesses as well, not just from the timber side. So this is quite an interesting project. And it can actually be a little bit related to the problem or the question that was talked about in the last project here. Just show you this image when we had our first meeting at the top of Mjøstornet, one of the tallest buildings at that time. It opened a month before we started this project. But tall timber buildings, we build taller and taller. We started with 5 stories in timber in 1995 or 96, going up to 19, 18, 19, 20 stories now. And what happens when we build taller? We get into kind of new problems that we haven't dealt with before. And one of those is actually related to human health and comfort as well, meaning that tall buildings, all tall buildings, no matter of the material, will respond to wind loads, the changing wind loads with accelerations. And if those movements at the top of the building are too large, it will be uncomfortable. If they're even larger, you can get motion sickness and fear. And this happened at quite low wind loads, actually. So this is something that we need to take into account, which we didn't need to worry about before. for a steel or concrete building that is heavy, you need to build 50, 70 floors before this is a problem. But for timber, we actually encounter this problem much earlier with lower load buildings. And we are talking about dynamics now. We have three things that we actually can control for the complete building. It's the mass, it's the stiffness, how stiff is the building, and the damping, how fast do the movement stop. And we have these three factors. It's the same also if we go up to a complete building with the wind load upon this. And the mass of the building, that's something that we actually know quite well. But we don't really know how much load from people inside and furniture and so on we should include here. Stiffness, we know a lot about, but this is in the serviceability limit state and at quite low load levels. And we saw before when Carmen presented this morning about the stiffness of connections, then it was one connection and there was variability. Now we have hundreds of connections in the building. So what happens when they act together? So we know how this is designed, but when it's built, what happens then? So we need to actually measure to see what happens in the complete building. And then we have the damping, which is a value that we can't even try to model at the moment. We need to measure something. And we need to know these values for complete buildings to actually be able to design these better in the future. So what was done in this project is that we actually wanted to measure some of these tall buildings, the full-scale buildings, to see what happens, how they really behave. And for stiffness, we can say we calculate in the design with a load-bearing structure, but we have walls that we don't take into account, but they have shown to have quite a large influence on this. And we had 9 buildings, actually 8 of them have been measured with forced vibrations, from 2 in Norway, 1 in Sweden, 2 in UK, 2 in France, and 2 in Slovenia that we ended up with measuring. And here we had some problems with COVID as well, because we were supposed to have the people from UK traveling around the whole of Europe doing this. And they were supposed to measure in France in March 2020, and we had to cancel the week before. And then we had to move everything forward. So that was a little bit of a trick with this project to actually manage to do this. But we finally managed to do measurements in all the buildings. And here you can see the equipment from University of Exeter that were experts in measuring this kind, with a lot of equipment on top of this 7-story building in UK. This is the small version of their equipment, I can say. It took them 2 days just to unload it and place it into the building. When they were measuring Mjøstornet in Norway, they had 600 kilos of steel plates with them as well that they had to move up to the top of the building. So this is the equipment. You can get some result. Here we can see the results from the building in Sweden, where Linnaeus University actually had to buy their own equipment to do this testing. This building, which is not that tall, have been equipped with accelerometers all over the building on the outside, which was quite an adventure with 25 meters up and placing accelerometers on the outside. But we can see that we can actually capture the motion of this building quite well. A little bit exaggerated. If you're sitting on top of here, you will actually, if you know that we are measuring, you can feel it. But the people inside the building didn't feel anything actually, even if we were measuring until midnight one night. And this is the building in France. We can actually also see that this building was measured. It's an 11-story building. It was measured 2 times. And what we can actually see is that in an unfinished state, and then they added more walls and more mass on the floors. And we can see that the, in this case, frequency is changing when adding mass and adding stiffness. So we know that these non-load-bearing structures have an effect on the results here. And we need to include that in a model for this type. So now we have values. Now we need to actually, that's one thing to measure on a finished building. Now we need to actually model them before. So we need to see how can that be done better. And we looked into details and assemblies. Still quite large. This is an 18-meter long truss in glulam that was measured and modeled to see how can we actually model this for these quite low loads. And a complete building, looking into different types of modeling, which parameters are important. In this case, it showed that the foundation was actually quite important as well to include, not just the timber structure. In this case, it's the one of the buildings we were measurement on in Slovenia. It's the new Inner Renew building that was going up during this time. And here they started with modeling. The one on the left is the concrete and steel parts that was included in model first, and then they also included the CLT around that to model the complete building, to look at what happened. And for Mjøstunet in Norway, which is from an engineering point of view a perfect building to actually model. It's so simple and not so much quite square in shape and so on. But where they also looked into which part of the structure is the most important one to include in the model to get the results that actually describe the building we have now. And in this case, they could actually see that it's very important. What are important is the stiffness of the diagonals here, or actually the connections in these steel. So we go back to, we need to know more in detail how the connections behave, connecting back to some of our other projects here. But then they can see that the next most important parameter to actually include is the facade, which is something we, for a structural model looking at strength, we don't care about because that does not take any load. But in reality, in these low load levels, it do take that. So we probably need a special model just looking at the serviceability limit state for load levels, and then another model when checking strength in the end. So what we are planning, what our impact and recommendations from this project will be, is that also in this project we have promised to write guidelines. It was supposed to be designed for serviceability of tall timber buildings. That showed to be a little bit too wide scope, so it has gone down to wind loads and serviceability at least. But it will give some recommendations on how to model this type of building to actually get a model that represents the reality later on. And we will have present data regarding damping, which is something that was not included at all in Eurocode at the moment. So it's some numbers that's necessary to include in the Eurocode in the future for these type of buildings. And we have had designers into the project from our companies that actually also say what kind of data do we need and what kind of modeling data and so on to actually do this do we need, and that will be included in this guidelines, which we still have to write, at least the last part of it. For property owners and developers, this will have an increased assurance regarding tall timber buildings. What they design is actually what they get, because this is still a little bit unsure. We can actually see from all the measurements that is done that the buildings are actually stiffer than the models say. So all buildings have been designed on the safe side at the moment. So we can probably optimize them a little bit more than what is done today, which is the next step. And for researcher, we have measured 8 buildings here. That's a lot of data, a lot of work, but it's still 8. The spread of this is not that large. In the future, to actually be able to be a little bit more assured that it will be necessary to do more measurements. Therefore, one of the chapters here will be about how we think that you should measure this in the best way and which data to collect. So we actually can build up a database for the future in this. And there will be data that will be included in the Eurocode development in the future, hopefully. And this, we also had this COVID with just this moving of equipment, which caused problems. That actually led that when we started this project, there was equipment in 2 countries in Europe that could measure this. Now there are equipment in 4 countries, or 4 organizations that can do this instead. We had to change the project like that. We could also see that the codes for serviceability limit state, they are quite unsure. Looking at comparing Swedish code, Eurocode, the American code, the calculations of this type of acceleration actually varies by 100% from one code to the other. So this is an area that has not got much attention earlier, so that we need to look into this again. And the same is, we can say, for the limitations for accelerations. We don't really agree from country to country what should be the limitations. So that is also something. And we can say that the University of Exeter, together with the University of Bath in England, have invested in huge shaking tables where they can actually put people into onto this table and then shake them with these accelerations to see what they actually think. We tried that. We actually managed to go to UK for a meeting in December last year. We were lucky. We went there, and the day after they closed the borders again. But then we actually could manage to see what kind of values are we actually designing for. And you could definitely feel the limit that we have today. But we could also see that this has led to an increased interest in this human comfort issues. And that we need to focus on that as well, not just the strength. We need to move forward in this, what we actually design for. Vibrations, acoustic, health, as we talked about before, and so on. So that is also something that we see. And here is the list. We also have a homepage and a LinkedIn account that we can actually see quite a lot of what is happening. And here's contact details. And we can also show this image from June, when we managed to go to the even higher building, taller building in Skellefteå for the final meeting of this project. With that, I say thank you.
Thank you very much, Marie. Other questions? Yes? Two questions.
Very impressive. Thank you very much. We talked and we heard fantastic presentation results related to fire safety. The taller we build, there's one issue we do not talk about, but my question is, and you're an expert, we should also talk about water incidents. Because if you have this in wooden buildings and it can happen, let's say on the 30th floor or something, this can immediately lead to an instability which you do not find with other materials. Well, how do you see that, or what should be done that we can build higher and safer and have more comfort?
Water, that's also a good question, which is almost also impossible to get information on, because no one wants to tell when they have water incidents. There's one problem. Now, I think we will actually need to look into that, and also what happens. I think there's research needing to be done. What happens when we get water damage, and how do we actually get rid of the water and eventually change pieces of timber here? And that's an issue that hasn't been looked into. I haven't seen anyone doing that. We really need to do that.
But it can cause the biggest problem.
Yes. I agree. But there's still a lot of questions on that. Also during manufacturing of this, or assembly of this building.
Okay, now, yeah, you will be next.
Hello, Rosario García Gil from SLU, Umeo. Yeah, I mean, it's fascinating to see that in the future everything is going to be built out of wood, or majoritarily of wood. But then I keep wondering, we need to produce that wood. That's a lot of wood. And then I guess on the table of the architects, in my imagination, there must be this question, how to minimize the amount of wood we will utilize in this building. I guess, guys, you are developing amazing inventions on how to build a building with the minimum amount of wood, right? And that's still solid.
Yeah, I would say that that's one of the questions that we also need to address. These buildings still require a lot of wood material, especially if we build with CLT, which is a lot of material. There must be developments to do in that area that hasn't been done yet. But we also have this with using recycled wood as one source. We probably will need to do that in the future.
And one more question up here.
Thank you. It's Johan Fransson here from the Linnaeus University. Thank you very much for a nice presentation. I'm wondering a little bit about the foundation. You mentioned a little bit about this in your presentation, but could you elaborate a little bit more on that? I mean, thinking, for example, in Japan, I mean, they take care of this in a quite good way, I think, for earthquakes and so on.
Yes.
But could you mimic that concept into this wooden building constructions, or what is the thinking behind the foundation?
This was more to do with the fact they have concrete foundations, all of these buildings today, and that will be necessary if you have a tall building that needs stability. It's just that you can't just look at the timber building, you need to also look at the stiffness of the foundation, as you do for all tall buildings. That's mainly. The issue of building foundations in timber is something else, and that I think there are examples of that as well, but for small buildings in that case.
Nice, thank you. Okay, and now Boris Azinovic is coming now on cross-laminated timber. And welcome.
Thank you, Karina, and organizers. My name is Boris Azinovic, and I'm coordinating the project InnoCrossLam. So what does InnoCrossLam actually mean? It is an acronym for Innovative Solutions for Cross-Laminated Timber Structures. Let's look first at some of the basics of our project. So it was a 3-year project, and we had a half a year of extension, and we will finish this September, so really soon. And our Slovenian National Building and Civil Engineering Institute, where I come from, is the leading partner. And we have also other partners from Sweden, Lund University, from Austria, Vienna University of Technology, from Germany, Technical University of Munich, and from Spain, University of Navarra. But this is not all. Our project has also several industry partners, which come from the timber processing industry, architecture, civil engineering field. And as you can see on pictures, we had several online meetings, but also some meetings in person. This was our last meeting in Sweden, where we presented our project results. And at this opportunity, I would like to thank all this amazing group. So it was, for me, an easy task to coordinate this project. So for the introduction of our project, I copied this word cloud in the shape of a tree. With the largest font, you can see the keywords that are the most important for our project. But if I summarize, so our project objectives were to increase the competitiveness of CLT even further. Especially, we tried to increase its predictability in these demanding design situations, which are not covered by the standards of today. And in parallel, we further developed a multifunctional use of CLT, especially in terms of its thermal activation. So our project was multidisciplinary, as all of them showed today and yesterday. We mainly performed experimental and numerical work. So to show the results, this is an image from our project application. It's a simple CLT building, and I'd like to expose this demanding design situations. So our project covered the design of deep CLT beams. So we did improvements in stress singularities as happening in point supports. Then we improved the design of CLT connections and joints. we did many work on seismic behavior of CLT-based structural systems, as explained with the thermal activated CLT, and also to design of CLT walls and slabs with openings. Our first mean of research was to perform questionnaire, digital questionnaire and interviews. With this we engaged with practice, and we got some general experience with practitioners doing CLT design. So our interest was to get the knowledge gaps of these complex design situations, so where they see the challenges, the problems, and how we could improve that. So we had over 150 participants, and also I think around 10 interviews to identify those knowledge gaps. So then the second mean of our research was to perform experimental investigations on this special demanding CLT design situations. So on the image you see a CLT slab with openings. Then we looked into shear resistance of CLT deep beams and the mechanical resistance of CLT with sound insulation bedding, and many tests on, as shown by Marie before, with large CLT structures. Also we have large forces, and this means also that the joints can fail in a brittle manner, so that the CLT as a material can fail. So we tested also the high load bearing connections and their brittle failure. Then the thermally activated CLT. So our question was, is this thermal activation in CLT or solid timber structures actually applicable in practice? And for this reason we performed many experiments, mainly experimental work. So first on these images you can see the mechanical resistance, so the in-plane shear stiffness, the buckling loads, the torsional stiffness. But also since we have the heating and the cooling process within this thermally activated panel, the change of moisture profile over the cross-section can affect the overall curvature of the cross-section, and that's why also many experiments on changing of moisture was performed. And the last set of experiments with thermally activated CLT was with the fire resistance and resistance to cavity fire. So our last mean of research was numerical modeling. On this image you can see how complex crack paths in timber boards can occur, and our colleagues from University of Vienna developed new solution approaches, especially with the phase field model method for fracture, and improved this method. Then we numerically modeled a lot of engineering examples, and this is one of them. So we checked that wood moisture content progression over the CLT board thickness, and then we compared how the partially sealed and the fully sealed CLT end grain surface and how this affects the moisture profile over the CLT. But also in relation to the last project presented, we did a lot of work on buildings, we designed, we suggested some new modeling approaches, especially for seismically resistant CLT structures. And at this point, we were joined and at one of the structures that was measured under DynaTTB project. And with our modeling approach, we showed how the results are well comparable with what they measured. Talking about the impacts of our project, it has a large impact on a wide range of stakeholders, wood processing industry, architecture, structural design, timber engineering research. And I have to say we've published several scientific and professional articles, and I invite you to read them, and they are accessible at our webpage. I put the address here. So we tried to implement user-friendly design rules, some modeling approaches that can be used by a wide range of engineers, and with this we hope we make the use of CLT easier for a large group of engineers. So we increased some of the knowledge gaps and improved the feasibility of CLT, also in terms of this thermally activated CLT panel. But of course, future research is still needed. I copied here our blackboard from our first meeting. So we had a full day of pinpointing the ideas and challenges and brainstorming. So I see our scientific cooperation really valuable to find consensus on these standardization topics and to shorten the period from research to practice. We had several benefits from sharing our resources, so research equipment and software for numerical analysis. And I hope that by combining these competences in several scientific areas, we also improved our innovation performance. As many of the project coordinators, I also here have to expose that due to the COVID prevention measures, we had some delays in specimen delivery and laboratory availability. We solved this by project extension. Then this also meant some difficulties to organize workshops for designers. We solved this by some online meetings. There was some barrier at the beginning that these national rules were not completely harmonized, so one of our partners started a bit late, but again, I hope this is now was solved by project extension. So all in all, we performed all of the experiments that were planned. However, I think some delay in final dissemination activities is to be expected. So thank you for listening.
Thank you very much, Boris. Okay, who wants to ask a little bit more about him? Yes?
I can maybe do it without, so I'm sorry to ask.
It's for online. Okay.
Yes. Okay, thank you very much for the presentation, and sorry for my ignorant question. What does thermal activated CLT mean? Because I must have missed that.
Okay, yeah, it was difficult to put everything into 10 minutes. Thank you for the question. So the idea is to have an airflow within the channels, so within the CLT, so to activate the panel, so you would not need the additional radiators and heating system. So basically, yeah.
Another question? Okay, thank you very much. Thank you. Okay, we're done with this part now, and now we will meet outside. Well, those of you who haven't seen the botanical garden in the morning yet, we will meet just outside here, right, Manu? Yeah, and then go to have lunch. I guess those who do not want to join can just stay here. Manu, you want to?
Yes. Okay. I think we will make it to make two groups, but I just wanted to let you know that for those that need to leave now or later, please let us know at the registration desk who of you might need a taxi, for how many people, and at what time, so we can arrange the taxis. Okay. Thank you. Enjoy.
Okay. I hope you're all full. I hope you had all a very nice lunch. Now we have 2 more projects to be presented. They are on the topic of service life planning of wood. And here something interesting happens because we have had 2 joint calls. And now the first project that is being presented is Clt Design. And they at Sadi will present the results from his project. And then Gui will come. And she's just starting a project on the same kind of topic. And so they have lots of connections. They have lots of same topics, but 1 generation after. So, and they already talked with themselves and will have already thought of some questions or connections. And yeah, so they will both sit down and then we'll have a smaller joint discussion on service life planning of wood. So at Sadi, please. Come here.
Thank you very much indeed, and good afternoon, everybody. It was an extremely good lunch, wasn't it? I saw a few glasses of wine going down, so let's see if we can keep everybody running and going. I'd also like to offer my personal thanks to the local organisers for arranging some rain to make me feel at home as somebody from the UK, so that's very much appreciated. Thank you. Fantastic to be here. As you will see, I'm a bit of an enthusiast around ForestValue and the energy this network has. So I'm delighted to be able to tell you a little bit about Clt Design, which has been running for the last 3 years. And our focus has been intently on this issue around service life performance, but service life information that's required. An absolutely fantastic project partnership, some of whom are represented in the room, Nibio. We also have University of Vigo here, I think, David. Yeah, fantastic. Who actually joined the project after it started as a self-funded financing partner, which was absolutely brilliant. But what was really important for this project was it was very much focusing on being pan-European. So it was really important for us to have representation from North, South, East and West Europe, as you can see across that partnership. We also had some really interesting input from Canada, from FP Innovations, a group that have done a lot of research in this space, and an extraordinary diverse industry group as well, some 23 different members, right from the engineering practices through to the wood product manufacturers. Really, really important for us. You have seen this slide several times before, those that are long in the tooth with ForestValue, but the proposition we're looking at here is around this rather sort of clouded uncertainty about communicating service life and performance information for wood products in construction. So if an architect asks what seems like a relatively simple question, they might get very different responses depending on who they're speaking to about the standards arena, some of which refer to reasonable working lives, whatever that is, some of which refer to product literature, of course, from manufacturers. But the whole thing is this cloud of confusion in that sense, and it really doesn't help those that wish to use wood products. We've talked about long service life wood products in many occasions in this conference already. So if we're struggling to answer those questions, well, hey, that's great news for the guys that are promoting concrete, that are promoting more homogeneous materials like plastics and steel and so on. And it also opens up, or it keeps open the door about getting wrong products in the wrong place. So not specifying the most appropriate product for the performance expectation in a particular end use. So all really, really important stuff. And the ambition behind Clt Design was to move from this very sort of complex and fragmented arena into something much more at your fingertips, much more usable, much more interactive. So the proposition across the whole story was obviously there's been a lot of research in this space prior to Clt Design. So it was to extract and cherry pick all the great work and the values that have been extracted from that, and particularly the relationships between particular exposure factors. The second phase was to then look at, well, where are the key gaps? The things we know have a significant performance impact on a wood product in service, and to plug those gaps. And, you know, within the minutes I have today, we don't have time to go into the details of those, but there were a vast array of different product tests and standards and exposures that were conducted to plug those gaps. But the real heart of it and the unique bit is that circular bit. So it's this story around decay and integrity, which are two sort of aligned elements that have a very significant impact on performance of wood. But equally, we have the aesthetic performance of exterior wood products is really vital and actually leads to some higher rejection rates than actually, it never gets to the point where it decays. It's changed color, people don't like it, they want to do something about it. And then being pan-European, very mindful of the fact of the risks associated with insects and termites. So it had to include that element as well to be relevant to the territories where that is one of their particular challenges. And then, of course, part of our story was about validating that. So it's building models and it's validating that with real-world examples. So the results, I wish I could kind of run through this live, really, but our most excellent colleague, Jonas Nikolowski from Lund University, on his GitHub site, which is located there, you will find everything that I'm going to show you there. And to be fair, the best thing for you to do is just have a look and have a play around and see how you find it works and how interactive it can be. But basically, what you'll see is you'll see 4 different modules of application. So decay, aesthetics, termites, and this integrity, so structural impact. Really, really important. You will also see tabs associated with support documentation and literature, and also something called EduPack, which I'll come on to in a few moments. But in essence, our decay module is applicable for in-ground and out-of-ground wood products. It takes you through, if you imagine all the different scenarios and impacts and influences on performance. Primarily, we've got to first know where we are, so location, you drop your pin on your map, and that is already now pulling up pre-calculated data about the moisture risk with that in a wood product in that particular location associated with either an in-ground or an out-of-ground application. It then needs to flip into detailing. The significance of design detailing and good quality execution is really paramount for many exterior wood products, and particularly those use class 3 applications, such as decking and cladding and so on. It then needs to pick up shelter, so we know that has a very significant effect, so neighboring buildings, actually the design of the eaves, all sorts of other features. Then we get into our material world, so which is where we kind of feel really comfortable. We know materials, what their durability classes might be, how they might perform in particular applications. And then it gives results. And you can see just some results here down at the bottom. It will impact the results of the change in the exposure dose from all those different choices that you've made. And then it will give you a service life in years for your selection of material associated with that particular exposure dose. And I think one of the primary things here is that this is a great sort of form of learning. It's learning by doing. You can retract back through your estimations. You can change parameters. You can see what impact that might have on service life. So really, really important and a very core part of what we've been doing. The other 3 modules are there as well. So there's an aesthetics module where you can select a wall or there are 2 test buildings in there. 3D information that can be span around and visualized. Again, what you're doing there is you're selecting material, you're then selecting an exposure period, and you can visualize how the coloration will change within your particular design and with that particular material substrate. You can imagine the amount of data that is behind that to enable that. The data about how wood changes color, different for different wood species over different periods of time, etc. And the ambition there is this is all open source. Anyone can access it, they can pick it up, they can advance this. So the ambition there is that an architect would be able to upload a BIM model of their building that has exterior cladding, and they would be able to visualize how it would look to their client in future over different periods of time. They might reflect on the specification of their materials. That's getting right materials into right applications. The termite module, it's not going to affect everybody. Scandinavia is safe, we think, at the moment from termites. At the moment, I do know that in the Low Countries, there is another outbreak of subterranean termites, so that's all heading into the news. But the termite module really is about drilling down into understanding where things are. So you have lots of different species of insect and termites and so on. Are they present? First question. Do I need to do things about it? So is there a national regulation like in France, the termite law, where I have to do specific things to protect against these organisms? Or is it more about hidden in best practice guidance within that particular country? So yeah, David and our former colleague Magdalena Kutnik from FCBA, really, really critical in supporting that element of it. And maintaining that relevance where actually in some cases this could be the primary driver for wood specification and certainly wood performance. The integrity model module builds on the aspects of the decay module, but it translates it into the engineering and structural performance of materials. That was conducted by VTT, very grateful to them. Again, you can just look at one of these modules, whichever area particularly interests you, or you can look at all four for your particular project. Again, that's about time span, material selection, protection selected for those particular end users. As I said, I mean, when I was thinking about this presentation, I think the best way to show results is the tool. That is the output. That is the result. But behind this, there is so much, I have to say, and so much work from the consortium about plugging those gaps, whether it's associated with the microclimates that you might be particularly encountering where you use your wood, whether it's about understanding the effects of splash water on cladding on exterior buildings. These are all new steps forward about generating that information. Whether it's about dose mapping up in the top right-hand corner, which is all about translating information we now have and the data access we now have about moisture in above ground wood to below ground wood. And that's using satellite technology to look at soil moisture contents. It's really connecting up very different data sources to enable that part of the model. And weathering tests and real buildings, all sorts of wonderful things. And of course, we wrote and presented and talked endlessly about this project. You can see the numbers and stats there, including 6 awards and prizes, which is pretty good going, I think, for presentations and contributions to journals and so on. But the one that really shines out to me is 33 students. So this is individuals who have either done a project, a master's, a PhD, or a licentiate study within this one project. Huge, huge impact. As an old stage researcher, this is the stuff that makes my heart sing, because this is the future. And I suppose building on that impact side of things, this is the first of a kind of this implementable tool. So it's there. It may not be the finished product. Indeed, we've spoken with some of the industry partners about how they might take that up and convert it into a much more user-friendly endpoint, actually, for their particular customers. But the algorithms and the development of those 4 modules is new. It's the first time they're in that one place where we can look at all those different aspects of performance of wood. The thing it has achieved in the world of standards, which as we know is very slow to move, slow to adapt, is it's very strongly influenced the N460, which may not resonate too much with many people. It's right slap bang in the working group that I chair within the SEN committees, but that is the pivotal standard that's been used at this point in time, talking about how a material will perform in a particular environment. So a use class and a durability class gives you an expectation around performance. That's all changing now. A new version will be published hopefully this year that will include much of the impacts that we've been able to demonstrate within Clt Design. 2 new projects developed, inspired by Clt Design, one coming very shortly in a few minutes from my colleague. And, you know, again, really, really focusing on supporting positive design. The key is good design and then positive specification materials on an understanding of performance. Well, the value of scientific cooperation, as I said, I'm a bit of a fan of ForestValue, the ERA, you know, the vibrancy of this community is absolutely fantastic, and I'm sure you would all testify to that have been part of it, or those that are new maybe coming into this. You see some slightly confused researchers at the beginning at BRE in 2019, and lots of happy researchers at the end in a renew this year. So that translation, the value of that multidisciplinary cooperation, as many of you have spoken about, absolutely vital. I also personally think it's one of the most efficient research networks that I've ever been involved in terms of delivering outcomes and fostering collaboration. And then I just have down here, just for a bit of fun, the 33 names. There are a couple of repeats because people then did masters and then PhDs, but that's 33 early stage researchers that benefited from those that are funders in the room, from your funding and your partnership in delivery. So that's a really amazing accolade. Unexpected things, of course, yes, COVID is a bit of a weird one, isn't it? But the first one I want to start with is we had initially anticipated doing a public tool, very, very simple, and a professional tool. We ended up merging because the two couldn't communicate. But our bonus was that we developed what we call an EduPack, which again is downloadable. It's part of that GitHub site. It's on there. And that's a whole series of videos that support the specification of wood in construction and take, so it can uplift those that might be a member of the public and not quite know so much about it, to the point where they actually feel, oh yeah, actually I can use this tool now to help me understand that. So that was a real bonus, something we had never anticipated. Fantastic work by Neshka in Renew. The COVID lockdown, of course, COVID lockdown did all sorts of strange things to us. I think the bit that hampered us was certainly being able to go out and validate with buildings. We had a lot more ambition about visiting buildings in 2021. Some innovative things that were looked at, so Google mapping resources, for instance, looking at exterior clad wood buildings over different periods of time. That was part of the story, as well as existing databases. So we have a database of 110 different exterior wood-clad buildings from a previous program. So we were able to revisit some of those. So there were ways and means, like many of you have said, it kind of creates ingenuity. You know, you create resilience by reacting to things, but yes, it's just a bit of ingenuity. You have to do something. And it worked very well for us. So thank you very much indeed for your attention.
Because we will have a joint discussion after, and you have prepared the presentation as one.
Perfect. Thank you. I'm really happy to be here, and I'm here to present this project, Enhanced Life Cycle Costing in Wood Construction by Novel Methods for Service Life Planning. I'm not the project leader. The project leader is currently in Hamburg. That's Professor Christian Brischke at the University of Göttingen. Our acronym is Wood LCC. So what's LCC? Life cycle cost is the cost of an asset, or it's the parts of that asset throughout the life cycle. Life cycle costing is the careful accounting of the life cycle cost throughout the life cycle or parts of the life cycle, depending on the scope of your study. So the project partners, you see them here. You see the academic partners listed and their logos to the left. And we have quite a nice group of industry partners as well that we are very proud of. The project started May 1st this year, and we already had a physical meeting in June. And now we have started our online Teams meeting. So why did we do this? Why did we initiate this project? Okay, tenders, according to the EU rules, need to be evaluated as the most economic, advantageous tender. And when you're in the design phase of a project, if you under or overestimate the service life, that will give both an economical increased cost and also an increased cost for the environment. And there's a lot of software out there doing LCC. And that's great. The problem is what's inside. It's the data inside. It's only generic data. So then we have our project objective. We will fix this by enabling robust and precise life cycle costing based on input from novel models for detailed service life performance specification for wooden components and buildings. And here, we have just started, but just to show where we're aiming, what we're going to give our input to. You know these modules. It's the same for LCA and LCC. We will look at the construction and installation phase. We will look at maintenance, and we will look at repair, the ones highlighted in green. That's what we're going to look at, and where we're going to give new data. Every project has work packages. Work package 1, and thanks to Ed presenting Clt design in a really excellent way. We are going, as you might have noticed, some of the partners are recycled from Clt design. So we are not starting on scratch. We already have 2 decades of work put into that model in work package 1. So the model from Clt design will be adapted and improved in order to give good LCC input data. In work package 2, it's all about the users, digging more deeper into who are actually the users, and we're also going to do a survey. The point is, in the design phase, like I said, the decisions you made there are make there is important, and we think that we can we can use some key questions. For example, asking, do you like painted wood or not? And if you say, oh, I love unpainted wood, then you need to double check. Do you really like unpainted wood? It's going to be gray in 1 year. If you still are okay, fine. Then, if you want painted wood, are you willing to do the maintenance, and what's your threshold? Because we need those limit states for different user categories. If you want a pristine white surface, you need to clean probably every year, a bit depending on where we are in Europe. But we know that already because we have Clt design. So we know already, you can look in that tool. And then we're also going to tap into social science, and we're going to do this survey. And my colleague Geir back at NIBIO, he's also good with both social science and statistics. So we're going to do this European survey, and it's going to link to the Big 5 personality trait system. So then we might get the answer, who actually like untreated wood? Is it only academics in urban areas, or do people on the countryside like it, you know? I think that will be fun. Work package 3 is sort of the core, because everything, that's the wood LCC, it's the wood, everybody is giving input variables to work package 3, doing the LCC, and then you will also have scenarios and case studies. Work package 4 is about design imperfections, and Andreas, you already mentioned what about moisture. We're going to help you. Because we will look both in work package 4 and 5. In 4, it will be, if you do small mistakes making water traps, how long time will it take until you get initiation of decay? And we will also look at that maintenance and repair inspection, the effect on service life. And in work package 5, we will look at new buildings techniques, mainly on mass timber, and see, because moisture is the clue, like you said, and to look at moisture safety methods. How much do they affect the service life? Then in work package 6, we're going to make this demo software and also this tool for virtual inspection. And everything, like every work package, is also feeding into this data platform. So expected results, just to do a summary. In work package 1, updated service life prediction model and service life database for LCC. Work package 2 is the survey and the quantification of limit states, because we know to learn to know the users better. 3, the core, compiled database with all the relevant variables and scenarios and case studies. That's the input to new LCC. But also feeding into that data for the imperfections, in inspection, maintenance, and repair intervals. How important is that? And then the moisture and new building techniques and the estimated how that will influence the service life. And obviously the demo software. And validation, always. So we will deliver digital specification added value, but the big core input is that input data from more robust and precise LCC analysis for wooden components and buildings. And we are confident that we will be able to deliver that, because now it's only generic data, and we already have Clt design, so yeah. The value of scientific cooperation. We all like sustainable, durable building materials. We like to build with wood, and we want wood to last for a really long time. This ForestValue initiative gave us this unique opportunity to put together different areas of expertise to move the work from Ed's project further. Again, we are confident that we will enable robust and precise LCC for wood exposed outside and in the building envelope. We just started, so right now all is good. Thank you for your attention.
Thank you both a lot. So now we open the floor to questions from you first, to the two. What questions do we have? Oh, there's one. Rune.
Rune Groven from the Research Council of Norway. Just a question from curiosity, maybe. It's probably described in the papers, but as a DIY carpenter and practitioner myself, it's also you notice that it's in the details where the what do you call it? The devil's in the details. When millimeters can distinguish between success and failure, would that be included in this model, or is it on another scale, from millimeters to centimeters to meters?
Yeah, so the first bit, I think, so if you look into the decay module, there is a design detailing element in there, and you're quite right in terms of capillary gaps between sections of wood. Millimeters is absolutely critical. The relationship as such has been constructed on the basis of our understanding in the data sets of how moisture behaves in wood materials and how it would behave in a non-ideal situation, such as butted end grain joints, for instance, or those that have a capillary gap to avoid movement of moisture. So there's an element of in there already. Yep.
And we have the EduPack, who's also giving additional details and so that's complementary. If you want to learn more, you have the EduPack.
No more questions? Oh, yes.
Yeah, just a question that popped to my mind when I was one of the last slides, just this 3 letters, BIM. As far as I understand, and I don't understand very much, this building information management stuff is very complex with lots of layers of information. Yeah, how do you think in projects running time, information from such a BIM model can be integrated?
That's where both in Clt Design and in Bud LCC we have the Sundocs at InnoRenew.
Yeah, so there was no time to present, but yes, there was quite a bit of work already done at InnoRenew on that within the Clt Design project. The fundamental there within an architectural BIM model that we worked with a few of the practices on was associating the material, obviously, with the particular element. And once you have your material identified in there, you can then attach data to that. Now, at the moment, it's not common, or in fact, it's unheard of, to attach performance information to that element. So it's turning it more into a live BIM scenario. So that point about being able to upload into the aesthetics model, for instance, would be quite a critical one, because your material would already be in there. You have your building, it's got your design detailing, your sheltering, or your exposure, and your material, and you can then connect that to what we know is the performance database for that material in that particular location where that building is proposed. So the work started quite earnestly, I would say, in Clt Design.
Yeah, and then it will just be continued in Wood LCC. So, and there also Richard, a PhD student who's really clever and working with the Sundocs. So, I mean, we promised a demo plugin, BIM plugin. So we're not promising the finished product, but I'm quite confident. I'm not an expert either, but I trust them. They're really clever, and it's since we're not starting on scratch, we're building on Clt Design, so.
I think you have prepared some. Shall I just click this?
I want to ask a question to the audience, because we're going to do a survey. And several other projects did surveys in their projects, but can you actually trust people when they when you because we will typically ask how often do you maintain your cladding, and if you want, everybody wants a clean cladding, and then you need to clean every year. And then do you think they will say, every year, even though they won't actually will watch Netflix and be on the sofa, or do they lie, or got anything to share on that? Or should... Can we get a microphone over there?
Yeah, hi. People tend to try to satisfy what they think you expect from them. For this, you need to build into the questionnaire trick questions that will then reveal those not so honest responses, complemented with how much money do you spend per year on this, or how you do that, do you contract someone? You know, then they will start to get tired of it and will stop answering, more or less. And those that are serious, they will continue. So there are techniques how you can actually check, and those that are trying to manipulate their answers, yes.
Okay, thank you. And we will also work with people more experienced. I'm not experienced one.
Yeah, there are tricks on. There was one thing just on screen here that just showing you part of the challenge here of what we're dealing with is at our Skellefteå meeting, we put up a part of a Menti poll which asked people to put down their expectation for service life for 3 different wood products. So a fence post, cladding, and a timber bridge. You can see there the spectrum. So we've got 18 years expectation for the post, 41 years for cladding expectation, and 63 for the timber bridge. 53, sorry, 53. But actually believe me, that's a little bit of a nonsense, because what you can also see there is the spectrum of results. So actually expectation around service life very much depends on who you're speaking to, what country they're in, or what region they're in perhaps, and how connected they are to that world. So you can see some pretty broad spectra for those, certainly those last 2 elements. But that's part of the challenge. That's why we need dynamic tools that can accommodate those differences that individuals might have.
Thank you.
That was it. Just a bit of fun. I mean, have we got... we've run out of time, surely. 5 minutes. 5 minutes?
No, we can continue.
Okay. Well, has anyone got any more questions? So again, it's one of these things where we can build on, and you all know this, we can build on the projects that have gone previously. So there was a project called WoodExter within the Wood Wisdom program. That did a survey of public and professionals. So that difference again, who are you? Are you a professional or a member of the public? About service life expectation, I think for 12 different wood products across 9 or 10 different countries. So there's some really great data sets there actually to enable us to take a more intelligent approach. But I will stop talking now.
Thank you very much. That was interesting. So now we have our last session called Past, Present and Future, and Andreas Kleinschmidt von Lengefeld will... He's preparing already.
I should do something like this now.
This, no?
Yeah.
Okay, and followed by this keynote speech will be a panel discussion with many people.
That's a keynote speech. So, good afternoon. Now it's up to me to take you on a trip, because my special gratitude and thanks to ForestValue and the ForestValue partners for asking me and to come. And they said, could you give a keynote speech about, in your point of view, what happened the last 20 years and what is your experience? You will see, I go back, does it work? So we talked about 20 years of strategic evolution. I used strategic evolution. I created my own company, which is called Homo Silvestris Europaea. And I think at the end of my presentation, you understand the name of my company, because I was actually surprised myself how much it fits to my own career, and that we all collaborated and worked together throughout the last 30 years and specifically 20 years on the European scale. What is also a surprise, which you will see, is that exactly 20 years ago, a major shift happened in research funding and program development. I was not aware myself so much of that, but when Mika asked me to prepare that, honestly, it was the longest preparation for a presentation I've done probably the last 15 years. And, but it should also be fun. So let's start with some European winners since 2002. And not so serious, but you know what I'm referring to, the Eurovision Song Contest. And I selected few of them. But what's interesting, just look at the logo. When it started, it was quite a little bit conservative, very traditional. How the logo is today, what's in the heart of the logo, what does it also reflect on our society? And when you look at all those different winners there, of course there were many more. The interesting thing is all of them, probably except Finland, does not really present the cliché of the country. We have never seen who's behind Lordi, so maybe Mika knows more. We do not know. But what I also would like to tell you, there's one thing very important. They all won because they were voted also by the society, by the Europeans across. So that's quite interesting, actually, when you think about this fun thing, how this has changed. And now I take you on a trip, and that was a quite long reflection. What has happened since World War II ending? And that is very important because Brussels and Europe is very much criticized, and I don't find this as in any way a right way to do that. We should also look on the positive sides, what happened. And very short, you see here the beginning after Second World War, you know, all the different steps which led to what we call today the European Union. And the interesting thing is when they signed the Treaty of Rome, forestry was excluded specifically. It was absolutely agreed upon forest should be out of the Treaty of Rome due to the ownership type, subsidiarity principle, and so on. But you see later it's coming there, I put it already up. What happened in between, and I'm not going through who are the countries where the founding members, so to say, who started that. I make a point here in the 80s, we were facing the first pandemic thing on a global scale, HIV, AIDS. And we know that in Kinshasa, AIDS, we know the origin of AIDS in Africa, and Kinshasa already had 2 outbreaks in the 40s, but then it came due to the relation with Belgium, it came to Antwerp, and then it spread around the world. It was the first pandemic. Still today, I think 30 to 40 million people live worldwide HIV positive. But why do I take this as an example? Research has developed that for those who have access to medication and treatment, it's not a death kind of like judge for you. It means you can survive, you can live as long as if you do not have HIV. This is only 40 years. What happened as well for the United Nations, the Brundtland report was launched. I put this in here because our sector is always saying we know that. This was the first time we talked about we have limitations in growth. It was mentioned also. And limitations in growth means we should have a sustainable concept. The sustainability concept was, so to say, proposed on the global scale. It was Europe who was the first continent then to say we start and we want to build on that. And then quite interesting, because European Union is only the as we say in French, the Treaty of Maastricht. So it's 30 years where we have the European Union, when we talk about the Union. And that caused so much interest. Also, it was not only the economy union or the things how it was started, it was also the social aspects, the political aspects. And in 1995, 3 countries where the forest-based sector and wood products play a major role in their economy joined the European Union. So that was Austria, Finland, and Sweden. And all of a sudden, forestry showed up into the discussion and also on the European scale because it has this importance and also they play the role in these countries. And I put in here the orange arrow, you will see the enlargement with the Central European countries is very important to know because at that point it all happened. And I didn't know at that point I started working on the European scale. which is coincident. So what does that mean? We talked today about the research innovation projects and the programs that fund them, and my gratitude to all the presentations, not only that your presentations were all brilliant the last 2 days, but also what you have achieved and the breakthroughs that have been presented. Here I have listed, and you see these are the framework programs on the European scale, how it started. I think Ed and I, we are probably the only ones who still know framework program 4 and 5. I do remember we were still young when this started, but you see how important all of a sudden the program also budget-wise have developed. And here we are, what I said, we have the enlargement of the European Union with the Central European countries. Why do I stress that? Because I want to stimulate you a little bit. You sometimes hear the instruments, you hear the requirements for the call, you freak out because you have to address some criteria which you do not understand. Everything is related to the political developments, and that is related also to the actual situation we are facing in Europe. So before that, the program FP5, FP4, I would, to simplify, say it's sectoral. If you work in wood, there was something called like wood, and you apply for the wood program. That has changed because then framework program 6, it was at that time Commissioner Busquin, when they started saying like we have a European Union, but we have different levels of research, we have different levels of innovation, of economy, performances, and so on. We want to create the European research area. That means we want to connect all the actors, we want to connect the programs, we want to see what are the capacities, we want to see what we can do, because there was a clear signal already that Europe is very strong in research and education compared to many other areas around the world. And then what happened also is like, and as funny as it is, so the Era Wood, I was the coordinator of that. The European Forest Institute had a second project for the forestry part. Ingmar Ford was the workshop 2002 in Paris. And this is all started. And you see that development of the Era nets. We talked about Wood Wisdom. We talk about Wood Wisdom Net 2, Forest Terra, Wood Wisdom Net Plus, the Some Forest, and today ForestValue. How they are following that, how they were important, actually could apply to become a crown witness for all of them, because on the top level, I was witnessing and collaborating on all of them and being involved. In 2005, there was on the European scale within the European Commission services, the beginning and the discussion of a program which is called KBBE, the Knowledge-Based Bioeconomy. And then we were setting up the technology platforms. We started the forest-based technology platform. 1,000 people collaborated with us across Europe to develop the first strategic research agenda. Then we started the preparation of big BBI to say Europe should become the leading continent for biorefineries, new products. We worked on the first white paper 2011 for the bioeconomy on the European scale. It was launched in 2011. Practically every region in Europe today has its own bioeconomy strategy or programs. We worked, the first EU forest strategy was launched 2013, and there was a budget available of 5 billion euros in the Regional Development Fund for activities in that. We have the COP Paris there. I was not involved. That was high-level political things. You know, when the agreement was we have to do something to combat climate change and become quite serious also in the understanding on the political level there is something where we have to work. This all led to the current situation, which is in such a high favor of our sector as we have never witnessed before. And all of you and everyone involved in the last 20 years contributed to that. We have a Green Deal. That is the European political agenda, targeting that Europe should become the first continent climate neutral in 2050. Many countries, I think Finland recently and others, declared they want to become climate neutral already in 2035 or earlier. We have the new European Bauhaus, and our sector has launched the Wood for Bauhaus initiative in that, which is quite nice and quite interesting. Very good also for the promotion. We have the policies also like Fit for 55, meaning the reduction of 55 energy consumption, carbon emissions, and so on. We have the white paper I mentioned from the Wood Circus, demonstrating what is the role of primary processing for the circular economy. We have the new forest strategy, we have the biodiversity strategy, we have the circular economy action plan. And what is new is the three are totally integrated, interconnected. They're not isolated. All three should be read together and should also be seen how they're linked. And in 2002, the ERANET started, because we also saw that on the European scale, sectors like us have problems sometimes. The woodworking industries is not doing research themselves, but they're totally depending on good developments in technologies and knowledge. They integrate, they implement, but they do not do research themselves. So there are also some topics which are not totally European, but which are very relevant for many countries in Europe. So the ERANET scheme that was developed by the Commission and also initiated led to the fact that that countries could join together, as it was happening with Wood Wisdom Net, and say, okay, we want to finance collaborative projects on specific topics of utmost relevance for us and our company, or our country, or even on the basis of the industry or the research that's carried out. You can read a lot of those. We have done an analysis, Dr. Uwe Kies and myself, for the SCAR group, where we analyzed all the cost actions and the ERANETs directly from our sector or even directly connected to our sector. And it's really impressive the work everyone has done and what has been achieved. And you see the number of the different value chains, the projects that are running, addressing them. You have presented amazing new projects the last 2 days with really breakthroughs and directly to be implemented, exploited. You see here, and I will not go into these details, how important these ERANETs are for the participation of small and medium companies and of industry partners who will feel lost in projects which have a running period of 5 years or 4 years, and probably who will develop some results that you can exploit or implement in 5 to 7 years. A small company cannot afford to do that, but in the ERANET scheme, they can say, we have a problem here, and we've seen that now, how you have worked on that. Sorry, what the results are. That's quite impressive, and we have identified, when you look at some of those ERANETs and you do not see industry participation, it's because they're targeting very important issues here, very much related to the forest ecosystems in the areas. So this was about the research programs. We talk about innovation, and then when you think about the last 20 years, it's quite interesting what happened and what really changed the world and where we are today. Here, just 10 days ago, the European Commission Services published their new scoreboard on innovation, and you see the different countries who are, so to say, high-performing in that. And surprisingly, they are the ones also very important for the forest-based sector, and they are very active, involved in the ERANET schemes, and also leading some of them. And it's just showing you how much this has also developed in the last years, and how, when you really look at the levels, how it's sort of like getting with this collaboration more or less to not really the same level, but it's not so far away as it used to be in 2004. So it makes sense to really collaborate and work there. 1991, what happened? Who knows? Quick, Robert, an idea? The internet. The guy who programmed the internet didn't earn any cent from that. He gave it for free. The internet was launched worldwide. It's 1991. So few of us probably still know the world without the internet. The majority of people don't know today. I put 3 in because we have the free internet, we also have the dark side of the internet, as you're aware of, and we have controlled internet in some continents. So you see what is happening and also how this is reflecting the development and how people use that. In 2002, who remembers what was the hot thing to be discussed and to work in? Nanotechnology, nanosciences. It was like the #1. There were big conferences and everybody believed it. There were sayings and studies saying like 60% of employment in Europe, new employment will come from nanotechnologies, nanosciences, and these applications. 2005, who remembers? He came with something that was revolutionary for the music industries. You had a small library on the iPod with thousands of songs which you could hear the whole day in a simplified way. It changed the whole music industry in a way that was unknown, and actually it created also a lot of new business. And only 2 years later than this came, the iPhone, the touch screen. It's only 2007, so it's in this case quite young, but that changed the world. And it changed in many things, which is now, as we've seen also with Ed, thanks so much what you presented. I think most of those things wouldn't be there if this was not developed and there. So here we are today, and the next decades to come. I know that people always don't like it, but I show you this picture because this is reality. Right now, we are under this kind of like umbrella. We have so many policies, strategies, programs directly targeting our sector, and we are the ones who can provide the right solutions and to fulfill the objectives. So starting from, of course, the Green Deal, but the new forest strategy, we have the Circular Economy Action Plan, we have the renovation wave where the Commission is estimating 70% of the existing building stock needs to be renovated to be more energy efficient and less consuming. We have the new European Bauhaus, and here I put in what I've on the biodiversity strategy and much more. There are also some working stuff, documents from the Commission directly targeting us. It's the first time ever where also the President of the European Commission, Ursula von der Leyen, uses the word wood many times in her communication, that it's a strong solution provider and something we should work on. And as you see, Europe, despite all the other regimes or continents in the world, is open and is welcoming everyone and wants diversity, because you have all stressed also the last 2 days the diversity aspect in your research projects that opened your mind and a better understanding for the problems you're working on. So here are some ideas. This is today, and it should give you the favor. We have AIDS still there, unfortunately, but not life-threatening if you have access to medication. So it's not kind of like, it has changed in such a short time that the research has provided all the solutions. It's not disappearing, it will probably never disappear, but it's not life-threatening. We see on the same time, and you mentioned all, of course, COVID-19, we have gone all through that together. It's there, it will stay, but we have in the shortest time ever in human history vaccination that works with a degree of more than 90% protection. It's also unknown. It was really in the shortest time ever, and people were complaining, and I was just partying when I heard the results. I couldn't believe it, how fast they were. At the same time, we live only on one word. We're totally connected. It's one click away, whatever you want, whatever can threaten you. And there's one very important aspect, that's girl power. This is why I put the Spice Girls there. The role of women becomes more and more clear, how important it is. And also, I mean, these ladies, the Spice Girls, have really changed also the music industry, and they opened the way for many other girls, ladies, whoever works in there. They fired their producer, and the macho culture in the music industry, they will die out now. They became stronger and more successful because they managed themselves, all 5. I saw their last concert 3 years ago in London. It was really fun to be with 85,000 girls and ladies and women at Wembley in London, and I was scared going home alone. But this is an aspect people never really understand. What does that really mean? The majority of students today on the university level are girls, ladies. So this is huge potential, and they have different. The young ones require different working conditions. They have different needs. Families will not be in the old model. It cannot work. So we have to think about that. And I like actually their slogan to say it's girl power. And at the same time, we have to face things which is unknown, and even the models cannot so predict. We have the impact from climate change, directly, indirectly, we have to deal with. So this is the current world, and some people see it very negative. Listening to you the last 2 days, I see it extremely positive. I think we have a future. We have to work on that, and it's only working, and you have all presented us in the collaboration. So one aspect that clearly has changed in the last 20 years is the citizens perception of our sector and also the way we live and what they require and what they want to have. So forest, people live in urban environments, and in Europe we are around 95% of the Europeans live in urban environments. But they identify with forests in a way which we are not used to. And they want to know what is happening, they want to be involved, they want to protect, and they are, so to say, they have what is really important. They also have a feeling towards that and a need and a desire. It was said also in the discussions in some presentations. I'm very happy to see that we talk about the health aspects. There are studies showing that if you're in a city, let's say like Paris where I live, if you sit next to a tree, your stress level is already going down. You see the effects. We have to work on that. And we have to connect and reach out to these people. I will not go to all the things, but the forests play a very major role, even if people do not live in the forest anymore. And this we also have to understand and work with that, and also with its products. So, muchas gracias, and I also would like to thank the organizers and everyone involved. I would actually like to thank everyone in the last 20 years I have worked with, and I had the pleasure to meet, and I'm impressed. I think you do a great job. I feel actually stupid when I listen to all your great projects, and it's a pleasure. And now I would like to raise some questions from the forest, and therefore I'm very happy, and thank you for the composition of the panel. I would like to call on stage Estela Fernandez from the Agencia Estatal de Investigación in Spain, who is from the agency, Mr. Robert Mafza from the European Forest Institute, the Deputy Director, Maria Rosa Mosquera Losado from the University of Santiago de Compostela, and who is also from the Spanish Agroforestry Association, Ratislav Raši from the Slovakian National Forest Center and from the Bio-East Forestry Group. Please, everybody come on stage. Karin Sandberg from Rice Institute, the Swedish Research Institute. And last but not least, also a dear colleague, Mr. Silvio Schuler from the Austrian Research Center for Forest, BFV. I think I have to say it in German because you wanted to have it in German. And also I would like to ask the audience, because I see you're all still awake, that you would, if you have questions, raise your hands immediately. After the 2 days when we were here,
Andreas, while you are settling down with the panel, so let's give a big hand to Andreas.
It was quite a lot of discussion already when we prepared the session right now, and there were a lot of questions concerning what shall I say or what do you want me to say. And I was thinking probably if we can start with you, and maybe Robert, I start with you if you allow. I have 3 warming up questions, and you just say what you think, kind of like, and how you, from your personal point of view, with your experience, your expertise. So the first one is, what would you pick out as the turning point? And whatever you think is your turning point, or for you a turning point, because it's diverse. We talk about diversity. There's not one turning point, but what do you think would be a turning point from your point of view in the last 20 years of research and innovation?
Good question. I would not say that there is one. There are several. Like, I mean, you collected everything well. All the slides, even the one on Eurovision, was showing quite many turning points, and especially the last one, maybe, where you had these 6 pictures. But for me, a turning point was really this European collaboration. Like that really empowered the knowledge creation, the knowledge sharing, and I think that for me it's something that is still not understood enough how important it is. I really think. I mean, all that you listed there, it's not only exponential growth of the funding, but it's the exponential growth of collaboration. I still think it has still a lot of deficiencies. It's a little bit developing like the EU. It still moves, but for me that is
Super.
Important.
Can I, Karen, ask you what you would say from your experience? You can talk as a what you think from your own research.
Yeah. Or I'm old enough to remember all the things you have said. But from I have been working in a research institute all the time, and I have followed the development also. And I think this, as you said, when Sweden, Finland, and Austria joined the European Union, we changed the regulations in Sweden. It made it possible to build high-rise buildings. And it was really a turning point. Then we started for this harmonization of standards and this cooperation in Europe. So that was a really turning point that made the, as you show, the Wood Wisdom Net project have been really, really important in this development and the cooperation, but also cooperation with the Nordic countries that we try to figure out how to deal with all these new things.
Thank you. Rajlev, can I ask you, what is your point of view? What would you say?
Thanks a lot for this opportunity to be in this conference and to say a word also to these important questions, how we see what is the turning point. So I would say that for us as foresters, it's important to consider forest and forestry in all its complexity and in principles of sustainability and sustainable management of forest. And as we consider these three main components of sustainability, of sustainable forest management, so we consider that there are those main groups of forest functions like environmental functions. From this point of view, the clear turning point is that we understood that there is climate change and there is significant impact on forest, and we have to join forces how to deal with that. So it's important topic which we understood clearly. We have to face it, and we have to collaborate because it tackles all of us. And it's important point, very important point, crucial point. Then from the point of economic view, I would see that the turning point is that we understood that we should somehow convert our economies towards bioeconomy and sustainability again, and to use more use renewable resources. And wood as such is like that, and we understand clearly that we are going in that trend to use wood in more and more fields of our economic activities. And we are going to replace those non-renewable materials in that way. And from that social aspect, so it's clearly that what was meant already by you, Andreas, that our society is putting on us some requests. They clearly know that they would like to have forests not only for wood production, but also for those social aspects like recreation, like sport, like relax, like healing functions, and this we have to consider, and that's the developing sector of forest ecosystem services and payments for them. And then I have to say, from my position, being here from Central and Eastern European countries, representing also the BioEast initiative, that the turning point was also initiation of BioEast initiative as such, which joins 11 countries and strives to improve bioeconomies, circular bioeconomies, based on knowledge in these 11 countries. And also this forum gives us to initiate new collaboration. So thanks a lot.
Thank you so much. Estrella, what would you like to say?
Since I am not an expert in research, in forestry research, I cannot find a turning point, at least in Spain, regarding your question. I belong to a funder, to a research funding agency, and before to the ministry, that was the main funder in Spain. And for us, as funder, the turning point was Horizon 2020. I mean,
why?
Because during the 7th framework program, our participation in partnerships was limited. Well, we were one of the partners, but it was somehow limited. And then, well, it increased. It increased in number and also in topics, in complexity also. And we were forced to integrate us, our agency, in this, I don't know, this landscape. And I think we did a good job. So we are partners in more than 50 partnerships. And I think we are doing good. I think
that means you have a strong will also to develop Europe together with the others. So you see the value of being there and do something.
I see. Of course, I see the value. I think it's obvious that there is a value in collaboration. There is also some drawbacks in this increasing complexity within the partnerships landscape, which are more and more complex every framework program, but still is very, say, encouraging and very exciting to be here.
You already point to my last question, which will come very soon. Maria, can I ask you first? What is your, just what would you like to say from the last 20 years was kind of like a turning point?
Well, thank you very much. I am very pleased to be here and be invited by the Spanish agency. Well, I am a researcher, or I was a researcher. I don't know. I'm not sure what I'm now. But I was a researcher at the beginning of this millennia, and finally, suddenly I just got the presidency of the European Agroforestry Federation. So I was able to be inside with the development of bioeconomy strategy, forest strategy, different type of strategy at European level through the civil dialogue groups. And the first thing I saw there, and I love it as a researcher, was that things should be done together with the different type of sectors and stakeholders. And this is for all the things that are related with the strategies that finally are spread or disseminated through funds, through their funds that follows these strategies. And because I'm an agroforester, so I'm in the middle between forestry and agroforestry. I teach in forestry. I am also teaching agronomy in my university. I think a good point was the establishment of the European Innovation Partnership, because it was able to understand that research should be done through, again, the collaboration between different stakeholders, so the multi-actor approach projects at the global level, but also at local level with operational groups. And this, I think, is the basis for the development of a better research and a better research dissemination from now to the next future.
Thank you very much. Silvio.
Yeah. Thank you very much. Yeah,
just one word, Mario, because Thomas is there and some other colleagues who worked also under the EIP Agri on the focus group 20 for the sustainable mobilization of forest biomass. I had the pleasure to be the coordinator of the group. We had several there and have a huge impact on the really, like, let's say, in the local conditions. So thank you that you pointed. I missed that on my presentation. I'm so sorry.
Sorry.
Silvio, sorry, please.
Yeah. So I think for me as a researcher, yes. so for me as a researcher, I think it was also the recognition of climate change within the research community and within the society, especially also among forest managers, forest owners, who now understood that climate change is a real threat to their business models and to what they have done the past centuries, to be true. So this is really, so I'm totally agree with Rastislav. This was really a huge issue. And I remember when I studied biology in the 1990s, it was a very minor subject. Of course, it was clear there is climate change, but it was, somehow a kind of a theory. And then even as a PhD working on in the department in northern Germany at the now Thünen Institute, it was not really a research thing, Okay, we all know climate change somehow, but no one did really research on that. And even if I then moved to Austria as a postdoc and developed my own group, it was still, let's say,
it took some time to really to grow up and to bring all the people together. And I'm happy that we were able to grow with that. And now we see the problem, and we see we are much too late. We should have started 20 years or at least 10 years for me personally, a little bit early on that. So I think this is a huge issue. And may I add a second thing, which is for the forest research, I think also quite substantial. This is our, let's say, our understanding that we need to do communication. This was a thing, if I look at a forest research organization that I worked for or where I cooperated with, let's say 15, 20 years ago, we all were sitting in our boxes, offices, and doing research and writing papers and being happy and being out there and then go to the next, you know? We cannot do that anymore. There is no chance. What we are doing in the forest, it has, or at least it always had a societal impact, you know, but it was not recognized. But now it's being really recognized that how forests being managed, how they develop, has a really huge societal impact, which is good, you know, because, okay, we get more funding, you have shown it, that's fantastic. But it also puts us in a much more responsible position, you know, because we have to much more take care of what recommendations we give, how we communicate, and to be true, we are, in the communication, we're really bad still, really, really bad. I'm trying to do that, but I'm really bad influence, I have to say, you know.
Robert is smiling. Would you like to say something?
Yes, I must say
please.
something, because this is like almost you are killing me here, you know.
So, not you.
It's excellent,
Please
excellent.
take the
No. You know, first of all, I think that everything that was said, I had the very bad position. I started, you know, and I wanted to be short and, you know, something that would a little bit relate to your slides.
You don't have to please me.
But I wanted to say, I don't think it's only the researchers, it's the whole sector. And I think that, for me, the big change came with this Green Deal, and it really showed forests are important, but very often we are stamped off as being the carbon sequestration storage space. Let's just put forests aside, all the rest of the people can do the same devastating things that they are doing, or all the other sectors, but you will solve our problems by not doing anything. And I think that this also opened up a lot of people's and foresters' eyes, which are traditionally very introverted, that, hey, we really need to make, well, not you or me, but that we really need to do something about communicating with other sectors. I would have loved to see here more architects, more urban planners, more agroforestry experts besides Rosa, I mean, and so on. So I think that really this is something where I also very much hope that in the next research programs, and ForestValue 2 will be such, this will come also more into play, and the Commission is actively pushing us into that direction with societal challenges, with, you know, bigger questions that relate to us. Yeah, bigger questions that we need to address through each and every project. I yesterday talked to
Mika.
No, to Mika. We were discussing that, you know, connecting also our research tasks to established policies. You know, the strategic plan for Horizon Europe. That's an excellent thing because it puts research really very targeted. I am talking about applied research. So I'm sorry that I made it so long now, but yeah, it was important.
This
to
is
say,
why you're here.
But I agree very much with Silvia's view.
Okay, we hear complexity and the attractiveness, the huge success of ForestValue and the predecessing aeronauts was it was tailor-made, it was focused, less administration, but we cannot avoid that the world is complex. We cannot avoid that we have currently a terrible war by Russia and Ukraine. We cannot avoid that the world is changing. So this complexity every one of you is addressing. Maybe Estrella, you were the first one saying it becomes more complex. What do we need from the research point of view? And do you really need to be a top-level researcher and at the same time a top-level communicator and at the same time a top expert in policy development and stratospheric understanding all the programs? Or what do we need in the complexity that will help us to address the challenges and to find the solutions? You probably already feel what I'm indicating to. Who wants to start?
Well, I don't think there is a person who can do all that. All what you said it looks impossible to me. So you have to work in groups, in teams, covering all those dimensions. But probably we are demanding, as funders, we demand too much from the researchers. Probably we are demanding too much. We are demanding policy briefs. We are demanding communication. We are demanding everything from one single PI, and it might be our fault that we are too demanding of one person or one team. I don't know.
Oh, look! The colleagues who are funded, they shake their hands. So Silvio, please.
Yeah, no. First, I totally agree. It's not possible that everyone is do everything at the same time. But let's say we have I think in Austria we have a very strong cooperation and communication also with our national stakeholders, and we try to we keep an open ear for them, and they also for us, of course. That's also needed. But I think what is not that you say you're demanding something, but also we need to acknowledge that this requires budget, that this requires person with these skills, and then you can build it up. So when I started in Austria at the BFW, we had, let's say, one guy. We started with communication, one single person who doing all of that. Now we have, I do not know, maybe 5 or 6 on that. And I try to have a half position even in my department by myself, just to make sure that it works. And this is even still, so we just need to recognize, okay, if there are funding, let's say funding programs, okay, each, let's say there might be an overhead of 20% or something like that, that needs to be recognized for communication, for a communication expert, for example, something like that. So that could be a solution, that it's not being put all on one person. Or as a funding program, you say, okay, let's build up a very close cooperation with the scientists, and then you have 1 or 2 communication experts, and then would not be Mika who's or Manuel who is doing twittering on that, but they are sitting there and twittering all the time, and they're getting to us and getting the information. Maybe that would be a solution.
Maria.
For me, of course, every time everything is more and more and more demanding. It means at the end more budget. I fully agree with you, but it's true that you need people that has a holistic point of view and the recognition that communication is needed, communication with dissemination with the stakeholders, the exchange of knowledge with the stakeholders is completely needed. So this person should recognize. So what I see that this have changed. Besides the budget, because with budget you can do a lot of things, is the fact that you need a more holistic approach for the person that is at least leading the project, because we cannot work forever in silos. I'm a researcher, I'm going to do micros of the wood, and I don't do anything else. And I don't care about anything else. No, you need to care about everything, because if you care, what you are doing would be more useful for the communicator person, would be more useful for the sector. That's the thing.
May I say something? Yeah. Yes. Would it be possible to externalize and centralize this communication? Because from our perspective, for example, when I have to fund one project, one Spanish partner in a bigger project, I don't want to fund only the communication work package. I want my researchers to do research. Yeah. And if they have to do some part of communication, that's okay. But I wouldn't like to fund just communication. So I think it could be also good to externalize that. I mean,
yeah. That's already a very important aspect how to do. Karen, you would like probably to say from your point of view. Please take the micro closer. And then here, raise your hand if you have questions to the panel. This is democracy.
Yes, as a researcher, we are, especially engineers, we are very interested in challengers. So this is all started on C. So we have a challenge, some kind of problem, and we want to solve it. And to do that, we need competence, the second C. So we have the competence and we have the challenge. Then we really start to, how should we solve this? And then we look for cooperation, the third C. So we have this cooperation, and then we start. And then we solve the problem in a way. And then we want to communicate because we're really eager to show off how clever we was. So usually it's not a really good idea to just have one to write because the one who have done it usually is the best, but maybe we need some kind of support how to write it and that help us. But maybe one communicator in a way, but usually we like to write reports and articles and tell about the things we have done. So, but the fourth or the fifth theme here is the continuation. I think the continuation is really important, and we have also talked about that today, that we have several projects that have linked into each other. We talked today about this Clt design, which based on wood extra. That was a wood extra program, and now it's the third one. But we have other example ready strengths also based on the Wood Wisdom Net project. So it's very important that we have this continuation, that we have all the new researchers that linked into each other, so we learn from each other over time.
Thank you. That was actually one super important. We have one question from the audience.
Thank you. I'm Katja Sonnenschein from the Slovenian Forestry Institute. Yeah, thank you. I think it's what you're saying really important. The sectors are cooperating. The communication is important. Continuation. And then I was thinking, we all know how important the forestry sector is for the transition to bioeconomy. And maybe other sectors could help, and maybe they don't have enough information, or maybe they don't have enough of the push. But if I think of the financial industry, maybe the taxonomy is making a failure, or there's not, maybe other sectors should be somehow better informed or get another push to realize how important their sector is.
Thank you. Rastislav, how do you see that from BioE's perspective?
Yeah, thanks. Indeed, each sector has to collaborate with other sectors. So as the society needs a variety of services and goods, so that's also the room for collaboration. And in this context also, regarding the development of bioeconomy within the BioEast initiative, so we established 7 thematic working groups. The forestry added value working group is one of these, and there is for agriculture, for wood, for freshwater management, then for education, then it's for smart biomaterials. So we are developing cooperation in that, exactly in that sense, that there are different sectors which are related. They should communicate to understand flows in individual topics, in the individual fields, and they to look for their overlaps and cooperation room. And in addition to that, to your initial question on that communication, so it's very important that there is established communication among researchers and policymakers. That's crucial. That's crucial. If this communication becomes effective, then also decisions and regulations which are in practice and are influencing the real economies are responding to the recent development. So that's very important. And in BioEast initiative, we do also in that direction. So in our thematic working groups, there are nominated experts from research, and then there are policymakers. So it's like twins represented. So countries are represented like twins of research and policymakers to understand what is the newest development, what are the trends, what is the recent knowledge, and what would be the best way how to implement in recent policies. So in that context, I consider, as Robert mentioned, that Green Deal was a big step. Indeed, it was. And I see that it was also thanks to research.
Yeah, I'm sorry, maybe I was not also clear enough. I thought maybe of completely other, not just sectors, but different, like in education, for example. Here in Madrid, there are how many business schools, and I don't think that they hear enough of sustainable development, or they're even educated in that way, what the wood sector could bring into business, or the education is really lacking behind.
Oh yeah, Robert.
Yeah, I need to say something. It's communication. Like all you said, I have a very simple answer. You need EFI basically for that. Why do I say that? It's not because I'm so arrogant. I am a little bit, but it's also because already, you know, the TFI in the early 90s, it was established as a research platform. But it was very clear very soon that just doing research and creating knowledge doesn't bring us any further. You need to connect it to those that actually make a difference. Not by influencing their opinions, but by showing them actually unbiased research-based information that might help them solving complex problems. These problems might be complex, doesn't mean that the solutions need to be complex. And the problem is that we are here dealing in parallel with other sectors that have huge budgets for communication, that have huge capacities for communication, because the communication cannot be done only by communication experts. Every scientist needs to have the capacity to communicate. And that needs to come through education in the first place, from small on and in the universities. You are not becoming a researcher just because you're introverted and want to be locked up in your office, but because you have to say something. You have to tell something to the society and to bring something. So this is one aspect. The other aspect is that we are dealing with other organizations like the NGOs that have huge communication budgets. You said you don't want to fund communication. So how do we do? Why not? Communication is as important as research itself because it helps us to transfer the knowledge, the solutions to others that are not involved in the research. And I think it's extremely difficult to get funded communication aspects in forest-related activities. And I think that this is a call to all the donors. Why don't we invest more into communication aspects? And the third thing, like what Katja was asking, yes, working with the private sector is another of the priorities that we see. It's true, the business school don't talk about forests. They see only planting trees is okay because everybody likes it. But they don't know how much more there is than to plant a tree. It's also how you can use it in a sustainable way. And this is also where we are working with the banking sector, with private companies, and so on, where we see that they're very eager, very willing to invest. Again, they're lacking the knowledge. They don't know, oh, if I now invest here, will I do something wrong? They have very high barriers that they don't want to become, you know, the company that did something badly in, I don't know, in Chad or in Kenya or somewhere else. So it's a lot. We really need to make an extra effort to communicate all our knowledge. And this is, like you said, it's continuous, but it has to come also from us, not hiring only communicators. They can, of course, help us to educate us, to show us tools, to show us manners, how you can do this more efficiently. But it's not enough just that we have, you know, a few more communicators around us and getting funding. That's
what I find interesting is I subscribe to all, but nobody mentioned actually everybody in the room is a communicator, and we should first of all also communicate among us that you have this great knowledge. We saw last 2 days so much new, important results, and now people going home will talk about that. You go. I'm sure all the researchers here, you must be inspired. Otherwise, you're not a researcher. Seriously. And I'm really more than inspired and motivated. And that's also something our sector we need to, and we also need, I would say, a very critical, good dialogue communication among us to find the right messages where we all say exactly that's it. And this is who we are. Because then it will happen. It's like the snowball. But there's another question from the audience before I also get back to you.
Tianli, ResValue Research in Norway. Well, we are here because we are doing ForestValue project. Actually, my question is that, okay, what do you think is the value of the forest? What's the value you think is the most? Because the reason I ask this is, before I joined ResValue Research, I've been researching in Norway for quite many years. All actually relate to kind of bio-based project. But then I saw myself in Norway, it's quite big change, not change, at least through different stages, like, oh, at the beginning it's like bioenergy. You just use the forest or trees, branches to power and heat. And then it's a push, maybe liquid biofuel. That's the value of the forest. And then now it's, again, a new center there, or several projects in Norway. It's like, okay, because it's a metallurgic industry in Norway, they want to reach carbon neutral. So they want to use biocarbon from the forest. And of course, now the people say, should we just utilize the forest as a carbon sink and try to maximum that potential there? So there's a lot of some of them, I know forest now probably still quite under development. But with the recognition of the value of the forest, there'll be more and more requests, I guess, to the forest. Yeah. What do you think, in your opinion, what do you think is the most value for the forest?
Yeah, it would be interesting if I have just a short, simple answer. Maria, you.
I just want to wrap up because I have several answers for the previous ones. With regard to the communication thing, there is a solution already given by the European Commission. You have different type of projects. You have the thematic networks that only the 2% of them are related with forests, where you gather all information and you make very beautiful documents to communicate that to the stakeholders and the rest of the people. So that there are the thematic networks, the CSA. You have the RIAs, which are research, where communication is less than 10%, and you have the IAs, where it is a communication directly, straightforward with the sector. With regard to the collaboration with the other sectors, well, I think for me, I am an agroforester. The other sector is agriculture. There are places in the world where the 40% of the timber is produced by trees that are grown outside of the forest. There is an example in the region of Odisha in India. And with regard to the last one, what is the value of the forest? I think we have to think globally and act locally. The needs of each region is different, and the possibilities of the different regions is different. So you need to have a bunch of methodologies to choose, just to get the one that is more relevant for the stakeholders and actors and even the society and the country in that specific moment. Of course, if you can combine them, like agroforestry, which mix food with good perennial production, that is much better. Well, how much consistent services you deliver, that could be much better. So I hope to have answered the question.
Yeah, thank you.
Can I just say,
yes,
if you want to know what is the value of something, try to imagine the world without it.
Impossible.
So infinite, I would say.
I think you had a brilliant question, very intelligent, but actually I think everyone here in the room has an answer, and it all together does not even give the right answer. We all have to enlarge that or work on that, because the value of forest is so multifunctional and has multi-values in all directions, so it's not only one aspect. And we are always trapped by this, that people say, we only want this, and then we start, yeah, but there is much more. But Silvio, I see on your face you want to make a comment.
No. I think Robert has said it very well. I would also say that forest itself has an intrinsic value that should be independently seen from our interest in that. So, and this is this is often, if you talk about ecosystem services, it's very nice, but we should also recognize this intrinsic value. But I totally agree to everything that has been said.
Thank you. Karin, you were smiling.
Yeah. This is a very relevant question because this balance in this value chain, at least in Sweden and Finland, have been very well balanced. Who get the timber when it have been cut down, where it goes in the flow. But now, when the request comes, it depends who is going to get the material. So it's going to be, so this bio-based circular economy will change the flow. And I don't think we really know for now how it's going to be, if it's the one with money or the market, or is it going to be a political decision. So we don't really know, but at least we know it's going to be changed. I think that's what we know.
Exactly, yeah. Any further quote? Because, yeah, Rastislav.
Yeah. I would just add that the value corresponds to our knowledge. When our knowledge is limited, we also value in limited way. And as our knowledge is increasing, also the value is increasing with that. As we understand more, we value more. So yeah. I would say it's developing. The value is developing.
Thank you. You have there's another two questions coming from the audience.
Yeah, it's a bit of an expansion actually on that that value thing, which I think is really, really interesting because, yeah, the multi-dimensional, multi-value aspects of forestry and wood, I feel we get a lot of tunnel vision. We get a lot of tunnel vision around, and these are good things, don't get me wrong, about low carbon construction products, because we know that that's a target agenda for somebody building or designing may wish to. What does the member of public think about that? Actually, their agenda might be the fact that they have a recyclable packaging on their throwaway instead of a single-use plastic. So I think that there is some really interesting, I don't know what the answers are, but this discussion has got me thinking about how we communicate as scientists. We have very traditional ways of doing it, of course, and we do it over and over again. But how do we take that information down to a more public-facing level about those opportunities and those, I think Sylvia used the term, those huge holistic benefits of forest as an asset and what it does for us? Because many of my countrymen, we are a low forest culture country in the UK. We used to be, in 1650, I think. You're not in Europe. we're certainly still in the continent. But the reality there is that people will not be interfacing with the forest industry and forest sectors as they do in some of the other countries. So that's some really, and they're huge consumers. So, there's some really interesting challenges there for us, I think.
Thank you very much. There is another question otherwise from the audience or a quick reaction, because this is exactly what we're always discussing right now. That has changed. The society's interest is probably different, and also the way businesses operating today has changed related to that. We see that also with the use of social media and. But please.
Yes, I have a completely different question, also regarding to the development evolution or whatever the last 20 plus years in research and research funding. What is your opinion of the development as regards to the degree of available funding for free, curiosity-driven research versus innovation and co-funding from industry and applied research, and what do you see in the coming years?
I like it. Who wants to start? Feel free.
Yes. As a researcher, I am and seeing the demands of the many projects and questions that we got. To be true, I see my role and also the research organizations where we are really mainly as an applied research organization. So, and I think many of the research organizations which are here on wood research or on forest research really have this role as an applied issue. So I would say, let's say we have 90% of applied research and maybe 10% of more basic curiosity research, or of course, as a researcher, harder would say, oh yeah, this curiosity research should be better financed for us. But we also see that other universities maybe are better on that, and we also, to be true, I also see that this applied research is much more needed at present to understand the problems that we are facing. Yeah, but of course, it can always be more of these basic curiosity-driven research.
We fund both. In our agency, we have programs to fund. We have programs to fund a basic research, curiosity-driven research, and we have programs more directed, but all of them are bottom-up. So there shouldn't be an idea that if it is good, it wouldn't be funded.
And there's a part on the European scale in the Program for Excellence. This was the European Research Council, and it's actually a fantastic program also for stimulating this research careers where you can build your career track already. And also, if you come from a field which is new or totally, as you said, curiosity-driven, I would like to defend all the colleagues who do applied research. They're also curiosity-driven. Even I'm curiosity-driven. But I think that there is actually a good development. And thanks for that question. I just would like to stress, even in our short and great discussion, we cannot cover all, but all is there. I can promise you. There are plenty of opportunities to find the right place, to find the right funding for your idea.
And I also think that these two types of research are not exclusive. You can do applied research and still solve basic questions in many cases. If you are now talking basic research is just, open-ended, do whatever you want, that it's not problem-oriented from the beginning in the application, then maybe that's different. But I see that applied research always offers also some possibilities for basic research. Because normally, from the agencies, you're not asked which method to apply or how to explore new methods or new ideas. They want some possible answers. And they're not even so strict on that, I have the feeling.
Maria.
I just want to comment on that. I think my perception is that we have more money in the last periods for applied research. And the main reason for that is that most of the research that we did was in a box and was not used by society. So there is more and more, which means that they just to have more sure, the impact is more continuous and at short term. It's like an adaptation. You have new findings because you do an adaptation to the real the for climatic conditions that you have. So you learn, and when you compare different conditions, you learn also. It's a kind of basic research. When I think in basic research, I'm thinking more and more basic subjects and topics. In that case, the basic research usually conducts to failures. But the thing is, when you have a success, you make a very strong change in the whole system. So I think both are needed for this reason.
Anyone else would like to comment? Otherwise, I have one final concluding questions. And now please listen carefully. I want just one answer from each of you. We travel back again 20 years, and we would discuss, and I promise you, because this is 30 years I'm in this business, the first thing is we need to communicate, better communication. It will always stay with us. So, and it's always right, absolutely right, and it's a challenge for all of us to communicate and reach out. Actually, what we want is that the other people get our knowledge. Isn't that what we want? How do we do this? The knowledge transfer. The other thing, 20 years ago when it started, the complexity. Our world is and will remain to be complex. It will never be simple. Even if we have a lot of populistic ideas today and people try to tell you there are easy solutions, they are not. And this is the other thing. So the Commission has launched some initiatives to group people around thematic areas. We are so happy that we are in the forest-based sector and working with forestry, which makes it more complicated because it's so diverse. What do you think would help us to go ahead and to advance and build a better future for all of us together in this complexity and diverse world we're living in, what would you like to have in the next 2 years from your daily work, or what would help you much more?
Only 2 years.
Only 2 years. Okay, 2 years.
Who have already been funded.
It can be just, because would be just by intuition, what would you say that would help me? Who wants to start? Yeah, Silvio, come on.
Yeah, no.
Okay, it's not good to sit in the center.
Maybe I mean you already communicated this kind of question, and I was a little bit prepared. So my issue and my let's say what we need as scientists, also as foresters, maybe let's say is to build trust. So and we are back at the community at the communication issue. I was actually yesterday morning in the 2 sessions where I presented Value 4, and then there were another projects who dealt also with the modeling and with ecosystem services and with these trade-offs. And I thought, and then I had I felt like 2 hearts in my breast. One was as a scientist, I think, oh, they have done very similar thing that I, or we, not I, that my team has done. And I think, okay, so let's see where we can publish that. And on the other side, I think to bring this knowledge to the people, you know, requires that we need to bring it to our Austrian people. We need to communicate it to the NGOs, to the foresters, and so on. And all of these studies, even if they are a similar study is done in Sweden than in Austria or than in Italy or whatever, that builds up, helps to build up this trust. And I think this could be an issue now in this, maybe as a common communication also for this program. If we would find out, hey, they have done a trade-off analysis of this and they planning that in a new project, and let's bring these back together, not in 5 different stakeholder let's say stakeholder letters, but in one stakeholder letter. So maybe let's say in a year, not right now, but maybe in a year we should come up and say once more, okay, all papers are now published, and now we are getting these very similar outputs maybe together and communicate it in a larger issue. Maybe. And now it's too early for that because we are still at the end of that, you know?
Very short, thank you.
Yes. Sorry.
Estrella, you already did.
Yeah, well, as a professional in my job, I would appreciate in this complex world that you have painted, I would appreciate some simplification. Yep. Very much. As a citizen, I would appreciate, and this is related to with the communication thing. I would appreciate some kind of consensus from the research community, from researchers regarding, in this particular case of forestry, the management of what's good for the forest management. In Spain, we have a debate now. What is better? Because we had horrible fires, and then the debate came. What is best? To manage the forests, to take off this shrub, I don't know how you say it, shrub, or not, or this is going to kill all the little mammals or little birds, and then the ecologists say no, you cannot touch the woods. So and this is something that the politicians use to throw bombs from one to another. And I would really appreciate that the researcher, the scientific community, in a way, can help the citizens to understand and not to be handled by the politicians.
Very good. You get already the line I want to conclude. Next one. Who wants to be the first? Please.
Yeah, it was a very good question, but. Always situation is developing and our minds are changing, but what I see in recent conditions, and coming from Slovakia, having border with Ukraine, I would say that in next 2 years I would like to have peaceful conditions for our work.
Thank you very much. That's absolutely perfect. Yeah.
It's me. So for me, not in the next 2 years, but in the next until I get my life off. I would be
next 2 years.
It would be just finding synergies, work as a teams. For me, one key issue would be to the bioeconomy development to promote the use of trees in agricultural lands. We have a project which called a European Union project coordinated by the USC called the Finite, where we developed 98 innovations related with how to handle the agroecosystem to produce timber of forest product from agricultural lands. Now we were given a new one, which is agroforestry for EU, that will start next year, and we are going to be focused on what are the best value chain, how can they be more profitable to help to have these trees in the agricultural land. So if you have anyone that could be of interest, we will be more than happy to evaluate it and to integrate it in the project. So that's my wish.
Super, and as you said, in the Mediterranean, I mean, forestry is food production predominantly, so it's very important. Carmen, do you have a wish for the next 2 years?
Yes, I think this conference is a good to show the importance of like this forest value joint 2017, that it was 17 projects and within forest-based sector, but within little different kind of research areas. But meeting like this, you listen to the presentation, you get inspired, as you said, and I think that start something, the wish of cooperation, you learn to know new people. So I think this continuation of this kind of meeting is very important to continue to meet and have new great ideas. And I think also this call for forest value, it was so many applications, and I think everybody in the whole Europe was engaged in this forest value call. So at least we have a lot of meetings, Teams meeting with colleagues all over Europe. So at least it had some kind of, okay, you are working with that and we are working with that. So I think this really starts this cooperation and see what other people are doing. So I think that's very important.
Thank you, Robert. Very short, one word.
No, well, one note, 5. Contribute to a more positive image of the sector in the public.
Thank you very much. And one last comment or question, please, because then I will wrap up. We run out of time.
I was just wondering, because you spoke a lot about communication to the general public, I imagine, to those shaping regulations.
Yeah.
But if we do not communicate among each other, how can we provide holistic answers? That's what... Yeah, exactly. Exactly, because I don't know anything what's ongoing in the forestry. I don't know what the forestry people know what's going on in the engineering sector.
This is
How
what
much?
we hear.
Yeah, but still, how does this change it then? Because now we all go home and then...
Then Mika has noted to organize the next meeting with the Forest Value projects. And so thank you very much, everyone. And I would like just to wrap up with one thing, and I loved it so much. Thanks for the word trust, because that's exactly what we need. And here I would like to give you the one thing. In 2005, when the Commission launched this technology platform, Mr. Sergej Beckelmann, who was the first project director, nobody knew what the forest-based sector technology platform will be. He asked me to work with him, and he gave me, that was the best advice I received from any professional in my life. We had sat together, and Sergej said, Andreas, whatever this platform will look like, because nobody knew, and whatever we will achieve, we will just see, but there's one thing we will do. We create good sleep for everyone who wants to work with us. And I thought that was the best advice, because in collaboration or whatever, communication in project is important. If your partner in a project has a problem or something pops up, if he or she informs you, you have the trust, okay, I know it will be delayed for 2 weeks, or there's a problem, or something is happening. So this is the trust. You create good sleep. And I thank you all very much for the 2 inspiring days. I'm very happy. I would really reach out if people around Europe are watching us. Thanks to everyone who worked and collaborated in the last 20, 25 years. It's a huge pleasure, and just look what has been achieved in perfect development of those programs, tailor-made. Thank you, Karen, for saying that actually everyone in Europe tried to be funded by ForestValue. So there are plenty, and many of good ideas outside there that needs to be funded and collaborated. Very special thanks to the Spanish colleagues for such a great organization, cozy, fantastic food, and the heartful welcome to all of us. Thank you. I'll have a safe trip back home, but I know Mika will now say something, and thank you all very much, and give a very big applause to our panelists.
Thank you. Yes. Thank you. So here you are. Yeah, that's right.
Thank you.
Yeah, this could be our
Carina, wo ist denn diese Forest Value Folie?
Take care.
Yeah. There's also one for you. So I keep this forward now.
I want to say thank you as well. Thank you. It was very inspiring. It's amazing that we cover all the topics from right in the forest, from the seedlings to, in the end, buildings, and even use of the forest, of the wood after the use. So it's like everywhere. It's amazing. Thank you.
All right, thanks. I will use this one so easier so that I can have my hands free, so to speak. So, ladies and gentlemen, what a pleasant 2 days we have had, and obvious. So everyone is eagerly waiting for the next meeting, and I would prefer to have it here in Madrid. So I'm looking to that it has been so pleasant here. But of course, we can gather together in Helsinki, wherever. But nevertheless, so in my opening speech, I told you that the Forest Value Action was officially started 5 years ago, and we then announced that our overall objective is to promote increased innovation and competitiveness of the forest-based sector in Europe and support its transformation from resource-intensive to knowledge-intensive, productive, resource-efficient and resilient sector. That was our humble aim. And furthermore, we announced in the proposal to the European Commission that the aim is to comprise a joint implementation of a transnational call for proposals for research, development and innovation in the sector, and with clear financial commitments from the participating national or regional research programs and the European Commission. And now, after listening all these 25 projects during these couple of days, I guess that we can certainly proudly announce that we have achieved the objectives and even exceeded the expectations towards our program. And despite all the challenges we have had throughout these past years, and everyone has named it when asking for these kind of problems occurred during the project lifetime, so the COVID has been hit by us all. Dear researchers and project stakeholders, I must say that you are doing most valuable work. It has been said already here several times, but please keep these words to you, so that we definitely mean it. And collecting these latest scientific evidences is definitely supporting European decision makers to base their decisions on the latest scientific evidence. And now when talking with our Commission officers who were able to attend here yesterday and today morning, so they were eager to get the information and more input even from us. So I guess that I need to come back to all of the projects to ask for even a kind of more comprised format of the impacts you have made at the regional level, possibly at the national level, and at the European level. So not just what you have shown here, but perhaps going even deeper with the impacts. And this is something the European Commission actually made me a wish, so that this is something I would also need to collect from the funders, so that to show to the European Commission that what are the real impacts then on different levels here. So they are really, really interested in seeing all this. And of course, I need to give my humble acknowledgements to the international panels we have used throughout the years for these calls, because we have collected the best experts in Europe, independent experts, to evaluate the proposals. As you all know, so the competition has been hard, and it has been also hard aching to drop some proposals because we don't have money enough for everything. But definitely, so the international panels have been of extremely valuable help to us. Without the panels, so we would never be here with these excellent projects you have been presenting. So my humble acknowledgements to all of the members of the international panels. We promised not to give out any names, so we won't, but they know. So good for you. And then I would love to say a few words still about the coming actions we are about to have. So in the opening keynote speech, so Nicolas Favre already announced that there will be this Euphoria process. So Robert, because your organization will be leading that action, so could you stand up and say a few words what the audience can actually expect during the coming months from us, I would say, because we will be working together.
Yes, so sorry, I'm again here. I like
Please.
Microphones, as you can tell.
Of course.
So the U4 project is basically a support project. Even though it's a research and innovation action, it will look basically into the past. So what has been achieved in the past 20 years. Basically, I should have Andreas to do this instead of work package 1. But nevertheless, so we will look at what type of research and innovation was actually achieved under the umbrella of European funding in the past 20 years. Then we will explore what do different stakeholders, including the society, expect from the forest sector, that we will conduct a type of a foresight study on what are the expectations towards us. And then we will co-design a partner engagement platform to actually jointly discuss and agree on a strategic research and innovation agenda for the forest sector in Europe, and also a roadmap how this agenda could be implemented. And all this is kind of the preparation for the forest partnership, which we would very much hope that would be then launched somewhere in 2025. So what you can expect in the coming few months, not so much, we will have the kickoff meeting 24th and 25th of November in Brussels, but I think after New Year then the things will start rolling, and then quite some of you will be contacting in order to either participate in some of our panels, either at the regional, local, or national level, or even at the international. So there will be quite some action going on in addition to what you will do.
Exactly. Thank you, Robert. Thank you. And then the second action, which is about to start soon, is ForestValue 2. We couldn't come up with any better name, so we simply, because I did no voting for this, but we were in a hurry in the springtime when we were preparing for the proposal. So Tony also remembers that we only put ForestValue 2 there in the proposal and thought, okay, let's go with that one now. And to our surprise, so it got accepted for funding by the European Commission, and we are supposed to get started now 1st of January. And there again, the aim is to launch a call or calls. So more information will follow. We are still in negotiation phase with the European Commission, so simply to fulfill some admin tasks there. But still the grant agreement also for that one will be signed soon. And then the funders will continue working together. A bit different setup there, and something else also showing up there during that one. So it's not normal type of ERANET as such, although the funding profile of the program will be similar to what you have now experienced throughout the years. So, but that will be then totally up to national funding. So the European Commission is funding only our joint activities within the consortium, but then the funding for the joint call will come from the national budgets, national and regional budgets. And about the communication still, so coming back to that communication issue, so need to remind you so that on the ForestValue website, so there's actually for these joint call 2017 projects, all these 17 projects, so we have collected so-called catalog of results, and that was a result of the Horizon Results Booster activity offered by the European Commission for us. It was free of charge activity, and all the projects now funded so participate in the first part of the activity, and then we collected all the results together, and on the ForestValue website, so every single project has listed 5 key results of their projects with some details, etc. So please go to the website and you can find the information there. And besides this, so we've also published a policy brief, just was it during the summertime, so we got it done. So we have not done any proper dissemination activity yet related to that, but definitely the policy brief is published on the website as well. So please go and check it there before we get it properly distributed. And I guess that's all from my side. And I would say that I can end with a quote actually from many great persons have said that the best way to predict your future is to create it. So let's do it, and let's make the world better for us, each of us. I wish you safe travels back home and all the best. And now I still would invite Manuel and Juan for the very final words as organizer. And thank you, Manuel and Juan, for everything.
My name is Juan Clement. I'm working here in the State Research Agency in Spain, and it has been a pleasure to have the meeting in Madrid. We are arriving to the end, but I come back to the beginning. 5 years ago, when we were discussing where would be the 3 conferences of forest value, and Estrella and me have very clear that we won't want here in Madrid. Yes. Why we won't want here? Because it acts as a 2-day hub where communication, dissemination, networking, and knowledge transfer is in the air. So this is like the start the engine for new ideas, for future projects, future startups, future ideas, in definitive. It was what it encouraged us to bring all of you here. And another thing is that it also approached to this event to all the Spanish actors in R&D and innovation. So that's why we are happy also for that. I want to thank you. We know that without you it's impossible, it has no sense. So I want to thank first to the researchers that were here presenting the projects, also to all the attendants and different actors, private actors, research infrastructure actors, to Mika for the excellent coordination of ForestValue, to Manuel for the organization of this meeting, and of course to Almudena, Patricia, Maya, and Irena, they are helping us with the logistic support. Thank you very much.
So just very briefly also to close the event, Juan actually told us a little bit going to the beginning 5 years ago. I arrived to the project a little bit later in 2018 when the co-funded call was being resolved. But it's been like 4 years and a half, almost 5, really active. I mean, we made I think a good effort. We got good results. Then we jumped to the additional call of 2021, which still be developing, still some more years for development. So I trust we will be able to also communicate and disseminate their own results. And as Mika mentioned, there will be also an extension and a continuation of this network. So I invite you to all to participate, and even if you are not directly involved, to follow all the news. And that's it from my side. As Juan mentioned, I would like to thank all the ForestValue organizers of this event, Mika, Karina, Katia from the core organizing team that like 4 or 5 months ago started to think about all the possible details. We came up with I think a very detailed agenda with a common thread. That was actually thanks to Karina that finally made it to create like sessions with a common thread, with a common sense too, and integrating the projects together with the same thematic. I mean, that's not an easy task. Thanking my colleagues at FECIT, Almudena, which didn't make it today, Maya, Patricia, and Irene, and all of you for being here, because otherwise we wouldn't be here. So thank you so much. Congratulations for your results, and I hope to see you soon, whether in Madrid, whether in Slovenia, whether in Romania. But I'm sure we will meet again soon. So thank you, and have a safe trip back.